Hey, this is Juan Tutors, and today we are working on the June 2025 Geometry Regents. I'm super excited about it. It's friendly regents, I think, out of the other regions, but there's a few pieces of advice that I need to give, especially for the geometry. You've heard me say it in other videos that are not geometry, but this is really much more important for geometry. You'll notice that the test says that note that diagrams are not necessarily drawn to scale. I teach my students to cross the words out for, especially for geometry, not necessarily, and write the words almost definitely. Okay? Just knowing that is often enough for the struggling student to be able to pass this Regents exam, believe it or not. Because if you just assume that diagrams are drawn to scale, it's almost always the case that you're absolutely right. Almost every diagram, in fact, is drawn to scale. And in fact, when they do geometry tests, it kind of has to be that way because they can't just break your intuition on purpose by making every diagram not drawn to scale, or even half the diagrams not drawn to scale. So in fact, almost every diagram is drawn to scale, and you'll notice that almost every test has like one diagram that's just barely not drawn to scale, if any, and then there's usually one diagram, sometimes two, that technically aren't drawn to scale because they still have some degrees of freedom, and you can't just assume that it's drawn to scale. But again, that is a test taking strategy, assuming that it's drawn to scale if you don't know how to do it. Assume it's not drawn to scale if you don't know how to do it. But if you do know how to do it, then do the work. But also check your answer by seeing if it makes sense with scale. Okay, so that's my big piece of advice. The next piece of advice before we go start on number one is, do you have to show work on part ones? Absolutely. Do they check your work on the part ones? No. But why do you have to show work? Well, because you'll notice that the part one problems are exactly like part two problems, just with multiple choices. So if you're one of those students, or maybe your teacher says focus on the part ones, if you're not showing all your work on the part ones, you're not really focusing on the part ones. You're actually not focusing on any part of the test. In fact, if you show work on the part ones, you're more likely to not even just get like if you're aiming for a 65, you're way more likely to get an 80 than a 65. If you show work on every part one problem, because then you carry that over to the part twos, threes, and fours, and you get all those extra points on the part twos, threes, and fours. With that said, here is the warning again. Note that diagrams are not necessarily drawn to scale. We cross out the words not necessarily and we put almost definitely. And that's the best piece of advice for the geometry regions that I could give, bar none. I am going to give other pieces of advice as I go on. Now, in terms of test taking strategy, I do want to talk about more test taking strategy during the test. However, I've been focusing a lot on process of elimination for many of my videos. But the problem is, if I focus only on process of elimination, I lose the ability to actually explain more. So I'm actually going to take the chance with the August Regents, which haven't happened yet, with the August Regents, and I'm going to do that entire test for Algebra 1 Geometry and Algebra 2, at least the multiple choice part, by all process of elimination. I'm going to focus on that one with all process of elimination so that I could actually do a little bit more explanation so that you can actually understand more and get more likely to get the answer right when it comes to the regions. That said, am I giving you methods to a process of elimination? Yes, I'm just not expounding on it as much as I normally would. Let's jump right into number one. The perimeter of a triangle is 18. What is the perimeter of a similar triangle after a scale factor of 3? A scale factor of 3 implies that the triangle is getting bigger. It's a bigger triangle. So that quickly eliminates 6 and 18. And because the perimeter's got to get bigger. But it is worth noting that linear quantities grow by a factor of 3 of 3 or by the scale factor. And the bigger lesson is that when you go into areas, areas grow by a factor of the scale factor, which in this case is 3, squared. Notice that area is a two-dimensional quantity and the exponent is 2. That's actually not a coincidence. Notice that nowhere in your schooling have you ever actually defined dimensions. They just kind of convinced you that we live in a three-dimensional space, and it took you a little while to understand that, but now you accept it. But they never actually defined dimension. The definition of dimension is actually that exponent. That's how you could actually define dimension. Now, volume grows by a scale factor, by a factor, not a scale, by a factor of the scale factor, which in this case is 3, to the third power. Again, notice that volume is a three-dimensional quantity and the exponent is a 3. The base is a 3 only because the scale factor happened to be a 3. So don't confuse the fact that there's a 3 and a cubed, that there's 2 3s written there. The base 3 is the scale factor. The exponent 3 is the dimension. And so perimeter is a one-dimensional quantity because it's a length. Since the perimeter is a one-dimensional quantity, it's going to grow by the scale factor 3 to the first power. I could even put a 1 here, the dimension, it's a length. So the perimeter, 18, times the scale factor is equal to 18 times 3, which is equal to 54. If you struggle with arithmetic, do not convince yourself that not using the calculator out of pride is a good idea. It's not. This is not an arithmetic test. This is a geometry test. This is, in fact, going to require you to do algebra, but they strictly do not require you to do arithmetic on the paper. So you could literally write down the arithmetic that has to get done and then plug that into the calculator and let the calculator give you the number. Totally legit across the board, okay? That said, number 2, the Washington Monument shown below is in Washington, D.C. It very much is. At a point on the ground, 200 feet from the center of the base of the monument, the angle of elevation to the top of the monument is 70.19 degrees. Here's the 70.19 degrees. And what is the height of the monument to the nearest foot? Okay, this is the first chance that we actually get to talk about scale. What does it mean for a figure to be drawn to scale? Drawn to scale just means that the parts that look proportionally the right size, the size given, are the size given. And so, without getting vague, I mean, a figure is drawn to scale if it's drawn to scale up to maybe a couple of millimeters. So is that angle, like if I took out a protractor, is that angle exactly 70.19 degrees? I don't know, but it definitely is bigger than a 60-degree angle, and it's definitely less than a 90-degree angle, and I'm pretty sure it's less than 80, so 70.19 really makes sense for that angle. And they also marked this, let's just be clear, they marked this as a right angle, and it looks like a right angle. The 200 feet can't be violated by any other lengths because there are no other lengths. So this figure is drawn to scale. So you'll see me write the letters DTS, drawn to scale. And so if we didn't know how to do the problem, but we assumed that this figure was drawn to scale, we actually could get the right answer. They're looking for the height of the monument. If this length is 200, then maybe multiply the 200 by some number to make a length bigger than 200, and we actually end up crossing out number 1, number 2, just from assuming it's drawn to scale. But we did confirm, let's just be clear about some notation. If we just didn't know, but we assume it's drawn to scale, we could put an X next to the answers because we suspect that they're wrong. But because we just confirmed that it's drawn to scale, which is an even better strategy, if you can confirm that it's drawn to scale, even struggling students can confirm whether things are drawn to scale. In fact, struggling students tend to be better at confirming that things are drawn to scale. So actually go ahead, try to confirm whether it's drawn to scale or not. It is drawn to scale, so the bottom's 200, so the height is going to be way more than 200. I'm going to cross those out. Okay, and so it's either 555 or 590. At this point, if you don't know how to do it, you could take a guess. but this is the opposite side. I'm colorblind, and that color is not working for me. So that's the opposite leg to the 70.19 degree angle. Okay, and this is the adjacent leg to the 70.19 degree angle. And of course, this side over here is the hypotenuse. And then I remember the acronym SOHCAHTOA. I had a student about a year and a half ago. I was actually tutoring a family member. Shout outs to Abby. And I was saying she actually wrote SOHCAHTOA in a way that I hadn't seen another student write it. I guess her teacher teaches it this way. SOHCAHTOA. And since writing it that way, I haven't had a single student forget what the sine, cosine, and tangent of an angle are. So I see we have the opposite leg that we're seeking, and we have the adjacent leg given. That's the opposite leg. So tan of the angle, I'm going to say tan of theta. Tan theta, or if you're confused about what this letter is, it's a Greek letter theta, often used to represent angles. Your geometry teacher may use it, but some geometry teachers avoid Greek letters and just use like the Arabic, no, the Roman letters that we use. Sorry, I said Arabic because we use the Arabic numerals, the Roman letters. So tan of theta is equal to the opposite leg divided by the adjacent leg. And notice TO over A. The opposite leg is the leg opposite on the opposite side of the triangle relative to the angle, and then the adjacent leg is the leg that's next to, adjacent or next to the angle. Notice it's the adjacent leg, not the hypotenuse is technically adjacent to the angle, but it's a hypotenuse. We're talking about not the adjacent hypotenuse, the adjacent leg, adjacent leg. So when we're talking about adjacent, we mean adjacent leg. So if you hear me say opposite, I mean opposite leg. You hear me say adjacent, I mean adjacent leg. Okay? At least in a triangle. So we got tan of 70.19 is equal to the opposite leg. I'm going to go ahead and call this H. No, not H, because H confuses the word hypotenuse. What is the height? Actually, they do call it a height. So the height, let's call it H, sure. Divided by the adjacent leg is 200. Now, if I put this over 1, then I could actually do cross multiplying. Students love cross multiplying. I used to not be the biggest fan of cross multiplying, but it fixed way too many problems in students' intuition, so I love it now. So H times 1 is equal to 200 tan of 70.19. So let me move this over a little bit. Okay, so H times 1 is H, right? Equals, and now we actually go to our calculator. Let's move this over since we have the numbers there. So we got to go to our calculator, we got to turn it on, and we got to actually make sure that we are in degree mode. So let's make sure that we're in degree mode. Enter, and let's quit that. I press enter sometimes twice just to make sure I'm really in degree mode. Quit. Now that we're in degree mode, let's type tan, 200 tan of 70.19. Okay. And that we get H times 1. Another lesson, H times 1, you do need to know that H times 1 is H. So H, or if you want, you could go ahead and divide by 1. You're going to find that you just get back the number itself. So H is equal to 555.2173038. You'll notice that I just literally typed in the whole number. That's another test taking strategy. And then I round. H is approximately 555, which is answer 3. With that, we go to number 3. on the axes below, triangle EQA and triangle SUL are graphed. Which sequence of transformations shows that EQA is congruent to triangle SUL? Is it rotating EQA 90 degrees counterclockwise about the origin and then translating 9 units right and 1 unit down? Or rotating EQA 90 degrees counterclockwise about the origin and then reflecting over the line x equals 4, or reflecting EQA over the x-axis and then rotating 90 degrees counterclockwise about the origin, or translating EQA 10 units to the right and then reflecting over the line x equals -1. Some important things that you need to know is that the letters in the congruence statement do matter. So the first letter vertex corresponds to the first letter of vertex. So E is going to be congruent to S. Q, the second letter, is going to be congruent to U. So Q, and it does look like a right angle. So I'm just going to mark it a right angle. It is a right angle because it's on the graph. Right angle there. And then A, angle A, which is the third letter, corresponds to angle L, the third letter. So I'm going to put 2 arcs there and 2 arcs on L. And now we have the corresponding angles. So we got to look for a transformation that maps one of these triangles onto the other. And all of these are going to transform EQA. So I'm going to focus on transforming EQA. First, I noticed the last one, choice 4, translating EQA to the right and then reflecting it over the line x equals -1. No matter what, is going to make a triangle that looks 3 to the right and 4 down, which, why did I get 3 to the right and 4 and 5, by the way? This is 4 and 3 and 5. So this does not match. No matter where the location is, this can't match this triangle. So let's go for some of these others. So it looks like 2 of them have rotating EQA first, 90 degrees counterclockwise. So might as well rotate it 90 degrees counterclockwise. So let's see. Now, how do you rotate a point counterclockwise? It is worth noting, if you have a point Q, if you have a point, I need a letter. Let's say a point P, X comma Y. If that's rotated 90 degrees counterclockwise, it is worth memorizing this formula if you'd like. It goes to P prime, and the coordinates of P prime are -y, comma, X. Okay, so that's a quick way of rotating a point counterclockwise by 90 degrees. If you, for example, rotate Q, the point, the coordinates of Q are 2 to the left, so -2, and then 1 up. Rotate this 90 degrees counterclockwise. That gets to Q prime. Switch the X and the Y, and then negate the Y. So I got 1, -2, and then I negate the Y, the first coordinate. And so I got -1, -2. So -1, -2, that's Q prime after a rotation. Similarly, E prime, which is at -2, 5, switch the X and the Y, 5, -2, negate the first coordinate. So I got 5, -2, that's E prime. So I'm testing right now choice 1 and choice 2 because both of them start with rotating 90 degrees counterclockwise. And A, -5, 1 rotates down -5 over 1 at the point -1, -5. So this is Q prime. This is A prime. And I have this and that and then that. Okay. And so that's my triangle after rotating 90 degrees counterclockwise. Now let's see if choice 1 or choice 2 transforms this triangle in just the right way. Choice 1 says translate the triangle 9 units to the right and 1 unit down. So that's looking good. First off, the orientation is looking right. We got a 4, a 3, and a 5. Now, if I go 9 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm at 8. That is correct. And then 1 unit down, I do end up at U. And then E prime does end up at S, and A prime does end up at L. So in fact, and how did I do that? Q prime, -1, -2, translate 9 units to the right and 1 unit down, transforms to, I'm going to call this Q double prime, -1 plus 9, and then -2 minus 1, which is equal to Q prime, double prime, 8, comma, -3, which is the coordinates of U, 8, -3, which is great. So, and then we do the same thing for the other points, or we recognize that since the orientation and the position relative to each other is exactly the same for triangle E prime, Q prime, A prime, and triangle SUL. We could actually see, since Q translates directly to U, all the other points are also going to translate to the correct point. So the choice number 1 we just confirmed is the correct answer. Number 4, if two sides of a triangle have lengths of 2 and 8, the length of the third side could be 10, 7, 6, or 4. And so the advice that I have for you is to actually just try to draw this out and see if you can justify any of these answers. Now, in the back of the test, there is some graph paper. So if we actually scroll all the way to the back of the page, back of the test, and we get to see that there's a formula sheet, but we see that the formula sheet for Geometry Regents now is pretty barren. It's a very simple formula sheet. So I drew over here a triangle. First, I drew a right triangle with a base of 2 and a length and a height of 8. And I see that this hypotenuse is really close to a length of 8. So I know a length really close to 8 is definitely legal. But then I thought about what's the maximum and the minimum length that I can make. And let me erase a little bit of this, okay? So if I open up this angle to be as wide as possible, then I get a kind of a degenerate triangle where I have an angle of 180 degrees, but then I have a distance from this point to this point of 8 plus 2. 8 plus 2 is equal to 10. So I can't really have a triangle of lengths 2, 8, and 10 because that would be a flat line segment. And in our geometry class, we don't have flat line segments called triangles. We just they have to have a non-zero area in our class. In other classes, it would be called a degenerate triangle. But yeah, so the cap on the length of a point from, let's call this point A, let's call this point B, let's call this point C. A cap on the length of AC would be 8 plus 2, which is 10. And in fact, if I drew a third side, instead of drawing it to the left, I drew it in this direction, to the right, a length of 8. Okay, it would go to basically right around there, and this would be point C. And then that would, notice that this C, then AC would then have a length of 8, because this is length 8, 8 minus 2, which is equal to 6. So again, we can't have a degenerate flat triangle, but it does put a cap, a lower bound on the length of the third side. And that, in fact, is the triangle inequality. Let's go back to the problem. And we just learned that the length of the third side, we could say, like, let L equal the length of the third side. And we learned that there's an upper bound and a lower bound to the length of the third side. The smallest that L could be, and in fact, it's a strict lower bound, is the difference of these two lengths, 8 minus 2. And the largest that this could be with a strict upper bound is the sum of the lengths of the other two sides, 8 plus 2. So the length of the third side has to be between 8 minus 2 is 6 and 8 plus 2 is 10. And so any answer, literally any number between 6 and 10, other than 6 and 10, would give us a valid triangle. And so the answer is whatever answer is between 6 and 10. And in fact, we see that choice 2 is between 6 and 10. So choice 2 is the answer. Let's hop right over to number 5. A regular octagon is rotated about its center. Which angle measure will carry the octagon onto itself? So for this, we're going to kind of do our best to draw a regular octagon. And you're not expected to be a perfect artist, but you do need to know that the prefix oct means 8. Octo means 8. So an octagon is like a stop sign, 8-sided stop sign. Okay. Let's draw it that way. And let's count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So a regular octagon has all the sides exactly the same length. It's kind of hard to see where the angles are. So I'm going to actually draw a dot on the angles. Okay. Okay. And now I'm going to label one of these points A, because it's going to help me see how much I can rotate by to get the octagon to rotate onto itself. Now I know that I could, if I rotate about the center by some number of degrees. Oh, and by the way, again, regular octagons have sides that are congruent to each other, and also the interior angles are also congruent to each other. That's what makes it a regular octagon. That's actually what makes it a regular polygon. So now if I rotate A by some mystery degrees to the right, to the in the counterclockwise direction. I don't know what this mystery number of degrees is, but it rotates A to that point. Now, can I actually calculate what that angle is? Yes. Actually, if I rotate again and rotate again, I 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 notice that if I rotate 8 times, I'm right back to where I started by rotating exactly 360 degrees. So if I call this angle of rotation rho, or if you want to call it P, rho looks like a P, but it's a Greek letter rho. For Greek people, shout outs to Greek people, it makes the sound of an R. They use a different alphabet than we do. Some letters are similar, some letters are not. So for example, an alpha is, capital alpha is a capital A. A lowercase alpha looks a little bit different. But anyway, so rho is the rotation angle, and we see if we rotate by rho 8 times, that's equal to a rotation of 360 degrees, because that rotated A right back onto itself. So if we actually divide by 8, now it's an algebra problem, and we got that rho is equal to 45. And so we actually know what the minimum number of degrees required to rotate a regular octagon onto itself is. So notice it's 360 divided by the number of sides. That said, 45 is not there as one of the answers. But we did remember, if we rotate by 45 degrees again, 2 rho is equal to, well, 45 times 2 is 90. 3 rho is 45 times 3 is 135. And I can keep going, but in fact, I already see, 4 times rho, 5 times rho, but I already see that 90 degrees is one of the answers. So in fact, the answer is 90 degrees. Number 6, an equation of a circle is x squared plus y squared minus 6x plus 2y equals 14. What are the coordinates of the center and the length of the radius of the circle? So it's choice 1, -3, 1, and radius 5, or choice 2, 3, -1, and radius 5, or choice 3, -3, 1, and radius radical 24, or choice 4, 3, -1, and radius radical 24. Now, this is what I call a 2x2 problem. 2x2 problem just means that it's actually 2 sets of details being asked about, and you don't actually have to analyze both details simultaneously. You can actually analyze each detail separately. So in this case, we could ask the question, is the center -3, 1 or 3, -1? And then we could also ask the question, is the radius 5 or radical 24? Now, I do see that there's that x's are there's terms with x and there's terms with y. There is a standard procedure for completing the square to write this in center radius notation. This is technically called standard form for the circle, as weird as that is, but we are going to write it with a center radius form. And the center radius form is x minus h squared plus y minus k squared is equal to the radius squared, where the r is equal to the radius, not surprisingly. And the center is equal to positive h, well, h comma k. Big note here, we're subtracting h, we're subtracting k. So when we actually calculate h and k, we got to remember that we are subtracting, the problem is subtracting h and k. So we got to remember the correct sign of h and k. So how do we get h and k? We're going to follow the procedure, the following. We're going to put the x's together, x squared minus 6x, and we're going to leave a blank. And then plus y squared plus 2y, and we're going to leave a blank. And we're going to say equals 14. Okay, now we could zoom into this a little bit now that we have this over here. Okay, and we're going to follow the following procedure to complete the square for both x and y. I'm going to make a table here. So complete, complete the square. X direction and in the y direction. And we write the value of b. B is equal to negative 6. So b over 2 is equal to negative 3. Negative 6 divided by 2 is negative 3. And then b over 2 squared is negative 3 squared, which is actually positive 9. Okay. And in the y direction, so we're going to add a 9 here, plus 9, before we go in the y direction. Add a 9 here, and then add a 9 here. And the reason we did that is we just completed the square. X squared minus 6x plus 9 is a perfect square. We'll address how to do that in a second. But notice we just added 9 and added 9 and added 9. Okay? The next part, in the y direction, b is equal to 2. B over 2 is equal to 2 over 2, which is equal to 1. And then b over 2 squared is equal to 1 squared, which is 1. So now we're going to add 1 and add 1. And we get another completed square. But notice that this one is this one and is this one. Okay, so now let's talk about the completed square. I said that x squared minus 6x plus 9 is a completed square, but what is it the square of? It's actually parentheses x minus 3 squared. And you might say, where did I get that from? It actually is gotten directly from this work too. Here, this minus 3 is this minus 3. Okay? And then plus the y minus plus 1 squared. Okay? Where did that plus 1 come from? Let's see about this color. This plus 1 is that plus 1. Okay? And then that is equal to 14 plus 9 plus 1 is 24. And now the radical 24 is looking great as a radius. And so the ones that say radical 24, so again, this is the radius squared. So r squared equals 24. Take the square root of both sides. Take the square root of both sides. Second, we get a plus or minus. And we reject the negative because the radius is greater than 0. Okay? So r is equal to radical 24. And so then any of the answers that don't have a radical 24 are just wrong, making choice 1 and choice 2 incorrect. And now we have a passing problem because we've eliminated 2 choices. But now what's the center? Remember that we're subtracting the center, so the coordinates of the center. So the center has coordinates. What we're subtracting 3, and also, well, we're adding 1, but what are we subtracting to add 1? We're subtracting negative 1. So plus 1 is the same thing as minus negative 1. And so we're subtracting 1, and we're subtracting 3, so the center is 3, -1. And so the problem that has these -3 positive ones are wrong. The ones that have a +3 and a -1 as the center are right. And the only one that has 2 check boxes is choice 4. And so the answer to number 6 is choice 4. Number 7, in triangle HSF below, the measure of angle S is 90 degrees. Sure looks 90 degrees. And the HF is 30. Nothing to contradict that yet. And FS is 23. 23 looks like a little smaller than 30. Great. This diagram so far, there's nothing else left to contradict anything. This diagram's drawn to scale. They said, what is the measure of angle F to the nearest degree? This is a great place to practice your drawn to scale skills. If this triangle is drawn to scale, then this angle looks smaller than angle H, okay? Which means that this angle F is less than 45 if the triangle's drawn to scale. Now, if you're assuming the triangle's drawn to scale, but you don't know it, you can cross out or put an X next to 50 and 53 because they're bigger than 45. However, if you confirm that it's drawn to scale, then you can actually cross these out. And in fact, we did confirm that this is drawn to scale because the 23 looks slightly less than the 30, but not that much less. Definitely not less than like 30 radical 2 over 2, 30 times 0.707, okay? Which is, a little less, a little around 21. So this is drawn to scale. So, but if we assume it's drawn to scale, that angle looks like it's less than 45. That's the test taking strategy. I'll mention it later on again. But how do we do this problem? This is the hypotenuse. And this is the adjacent leg to angle F. How do I know it's the adjacent leg? Because, well, the 23 is right next to angle F. And it's a leg, so it's adjacent. It's the adjacent leg. Okay? Whereas the opposite leg is HS. Okay, so going back to our acronym, SOHCAHTOA. We have the adjacent leg and the hypotenuse. So we're looking at cosine. Cosine of angle F is equal to the adjacent leg over the hypotenuse. So cosine of F. Now notice in this case, I think it's interesting because now in the previous one, they gave us the angle, they gave us one side, they asked us to get the other side. In this one, they're giving us the two sides, 23 over 30, and they're asking us to get the angle. I think that's cool. So how do we get the angle? We have to undo the cosine operation. Well, the operation, oops, dropped my paper. The operation that undoes the cosine operation is the cos inverse operation. So that F is equal to cos inverse of 23 over 30. And we go to the calculator. Okay? Let's put that over here. Let's go to the calculator. Now, you see that cosine is right over here. So then cos inverse is above the cosine in blue. So you press the blue second button, then press cos inverse. And then cos inverse of 23 over 30. We did make sure we're in degree mode. That's super important here because this is going to give us the answer in degree mode. 39.94. So F is approximately 39.94450519 degrees. And now let's minimize this. And so F is approximately, they said to the nearest degree, 39.9 rounds up to 40 degrees. Nice. Number 8, and by the way, you'll see repeatedly on this test as I'm scrolling, you'll see my logo and JuanTutors.com. Yes, I do tutor. Not surprisingly, these videos are for free. This is the free arm of my business. I do it partially to advertise my business and partially to give something back. But if you are interested in tutoring for yourself or your parents are interested in tutoring for you, we have not just me, we have other math tutors, we have ELA tutors, science tutors, chemistry, physics, bio, English, history. We have everything. We have a Spanish. We have a Spanish tutor, really phenomenal Spanish tutor. Shout outs to Laura, and shout outs to our AP Chem um, tutor Sean. So yeah, we go to JuanTutors.com and see if we might be a good fit for you. We have really great tutors, and I work with them directly, so I know they're good. Number 8, in triangle CAB below, mid segments DE, EF, and FD are drawn, and they do look like mid segments, but we have to talk about what those are in a moment. Well, let's talk about what they are now. So mid segments are line segments connecting the midpoints of two sides of a triangle, of a triangle. So are these the midpoints? They said it's a mid segment, so automatically you know that these are midpoints of their corresponding sides. Okay, so now we know that mid segments that DE, EF, and DF are mid segments, and that they split the opposite side, or the sides that they intersect, into two congruent sides, and we can use that algebraically. Two congruent sides, each one is half the length of the whole side, etc. So now they said if CA is 14, there's nothing there to contradict that yet. 14. CB is 20. That one does look longer than CA by a little bit, 20. And it, okay. And then FB is 9. What is the perimeter of quadrilateral DEFA? Let's actually highlight DEFA. Okay, so that is our quadrilateral that we have to calculate the perimeter of. Okay, and let's again repeat what we talked about mid segments. Mid segments connect the midpoints of opposite sides, and because they connect the midpoints of opposite sides, the opposite sides are cut exactly in half, which means that AB is cut exactly in half into AF and FB. Since FB is 9, AF is also 9. Okay, CA is 14. So DA is half of 14. 14 over 2 is equal to 7. So DA is equal to 7. Okay. And so now the perimeter is guaranteed to be greater than 9 plus 7, which is 16. Okay. And then if you're good at guessing, like this thing looks like a parallelogram, you might guess that it is a parallelogram. 7 and 9. So 16 plus 16 is 32. So this one's looking very, very good. But if you don't want to just guess and you want to learn it from me right now, then it's worth noting the mid segments, because you could actually prove this with similar triangles. The mid segments are also a length half of their opposite sides. So EF is half of CA. So that's also 7. Again, 7 over 14 over 2 is equal to 7. Okay. Let me write that in a different color. It's too many red things. Okay. 14 over 2. There we go. 14 over 2 is equal to 7. And the same thing, DE, being a mid-segment, is half the length of the opposite side AB. So DE is half of the 18. 18 over 2 is equal to 9. So this is 9. So just as we suspected. And so then the perimeter, in fact, of DEFA is 9 plus 7 plus 9 plus 7, which is, in fact, 16 plus 16, which is equal to 32. Or you could let your calculator do that arithmetic, but 32 looked like a great answer, and in fact, it is the answer. Number 9. A candle can be modeled by a pyramid with a square base, as shown below. The height of the candle is 10 centimeters, and each side of the base measures 6 centimeters. If the candle wax burns at a rate of 3.5 centimeters per hour, what is the approximate number of hours this candle could burn? Clearly, the volume is going to be required. And then when we get the volume, we got to think about what happens as we cut 3.5 centimeters, cubic centimeters off of it. So we can ask the question in the formula sheet, does that formula appear, the formula for the volume of a pyramid? And in fact, it does. The formula for the volume of a pyramid is V equals 1/3 base times height, where B is the area of the base. So V is equal to 1/3 base times height, where B, again, B is the area of the base, and the base is a square base. So it has a length 6, so it has a width of 6. So V is 1/3. The area of the base is 6 times 6 times the height 10. And we use the calculator to confirm that 1/3 times 6 times 6 times 10 is 120. Okay. Or you could do 6 times a third is 2, times 6 is 12, 12 times 10 is 120. Sure. Cubic centimeters, centimeter cubed. Okay. Now, think about what happens as you burn 3.5 cubic centimeters every hour from this candle. Well, then you're reducing it by 3.5 centimeters in 1 hour, another 3.5 centimeters in an hour, another 3.5 centimeters in an hour. This is actually a topic that's extremely important to learn in Algebra 1 so that you know it in geometry and so that you really, really know it in Algebra 2. It's one of the basic concepts. A repeated addition is multiplication. In fact, that's why we use the word times for multiplication. 3 times 8 means literally 8 added 3 times. 3 times 8 is 24 because 8 plus 8 plus 8 is 24. So that said, why am I bringing that up now? Because we are burning the wax at a rate of 3.5 cubic centimeters per hour. So 3.5 cubic centimeters the first hour, another 3.5 the second hour, another 3.5 the third hour, another 3.5 the fourth hour, another 3.5 the fifth hour. Each time we're burning 3.5 cubic centimeters. That's 3.5 added 5 times. That's 3.5 times 5. Another 6 hours, another 5 hours, 3.5 times 6, then 3.5 times 7, 3.5 times 8. We are adding 3.5 and a certain number of hours so we can get the amount of wax burnt by multiplying 3.5 by the number of hours. Okay, that's the big lesson from Algebra 1. Let H equal the number of hours burning. So we're going to write two expressions for the amount of wax that it burns. Okay? 3.5 times the amount of wax burning. So this is the amount of wax burned. I'm going to write that above. That's the amount of wax burned. AMT of wax burned. That's equal to, well, we want to burn the entire candle. We want to know how long it takes to burn the entire candle. So burning the entire candle burns exactly 120 cubic centimeters. And now we have an equation. We can divide by 3.5. We can divide by 3.5. That's slightly less than dividing by 3, slightly more than dividing by 4. So the answer's got to be between 30 and 40. We have one answer between 30 and 40, so this is looking really good. I said I would give you some process of elimination methods, right? And that's it. So let's get the calculator out though and confirm 120 divided by 3.5. And we get my test taking strategy, write the full number, 34.28571429. Let's minimize the calculator now. And that's approximately equal to it's a integer, so the 34.28 rounds to 34. Number 10, in the diagram below, tangent SR and secant STU are drawn to the circle O from external point S. If arc TU is congruent to arc RU and the measure of arc TR is 68 degrees, what is the measure of angle S? Is it 22, 34, 39, or 78 degrees? This is one, again, that if I go and say, you know, assume that it's drawn to scale, I can eliminate choice 4, and I probably would guess choice 2, although maybe that's my visual. I could be wrong. I haven't even looked at the answer yet, and now I'm going to look at the answer, but I'm going to keep it secret. That said, if I confirm that it's drawn to scale, then I can actually definitely eliminate 78. Let's see if we can. So they said TU is congruent to RU. Arc TU is congruent to arc RU. Okay, and those arcs do look like they're congruent. They do. They're arcs that measure way more than 90 degrees, but definitely less than 180. And then this arc measures TR measures 68 degrees, which means it measures less than a quarter circle. And a quarter circle, if I just drew a line and I drew a perpendicular line, that would be a quarter circle to here. So does arc TR look like it's a quarter circle or less than a quarter circle, but a little bit less? Yeah, absolutely. There's nothing else contradicting this thing. So diagram is definitely drawn to scale. So choice 4 is eliminated. Again, I'm going to do a lot less exposition on process of elimination on this test, but let's actually keep going and let's discuss how to actually do this question. Okay. So since TR measures 68 degrees, if I call this arc measure X, that means that this arc angle measure is also X. Then I can actually get what the value of X is by recognizing that the angle measure of a full circle is 360. So X plus 68 is equal to 360. I could subtract the 68, and combine these two x's. 2x is equal to 360 minus 68 is 292. Divide by 2, and I get that x is equal to, let's see, 150 minus 4 is 146. 146 degrees. And we got 146 degrees. Let's see. 68 plus 146 is, let's say, 214 plus 6 is 20 plus 40 is 260 plus 100 is 360. So that's right. So we just checked our answer. Okay. Now that we know those arc angle measures, there is a theorem that states when you have an angle, okay, an angle formed by by either two secants or tangents. So it could be two secants, or it could be two tangents, or it could be one secant and one tangent. Okay, then its angle measure is half the difference of the two arcs it subtends. Arc angle measures it subtends. So we can apply that's a lot of words, but let's actually apply some math to it. You see that angle USR is the angle that we're trying to measure, and we see that it subtends two arcs, one from point U to point R, okay, and then another one from point R to point T. So to put this in equation form, we're saying that the measure of angle S is 1/2 the difference between these two arcs. 1/2 the measure of arc RU plus, let's make sure that's a U, minus the measure of arc RT. So 1/2 the difference, half the measure of arc RU minus the measure of arc RT, which is equal to 1/2 of, well, RU is 146 minus RT. RT is 68. We can go to our calculator and put this into our calculator immediately. In fact, I actually suggest going into the calculator, but I will not. 1/2 of, let's see, 146 minus 68 is equal to 78. Yes. And half of that is, half of 78 is 36. 39. And so we have, I had guessed that the answer would probably be 34, but again, that's a 5-degree difference is hard to tell. And the answer did turn out to be 39. But I was really very close if I assumed it was drawn to scale. Of course, that was a really very good strategy, because guessing that it was drawn to scale actually gave us a 50-50 chance of getting it right, because 22 just seemed too small. 78 was way too big. And so the answer was between 34 and 39. Having a 50-50 chance of getting it right makes it a passing problem when we just assume that it's drawn to scale. So is it a good strategy? Absolutely. Number 11, triangle RST has the measure of angle S is 33 degrees, RS is 7, and ST is 12. What is the area of triangle RST to the nearest 10th? Fun fact, if you just guess 1/2 7 times 12, that gives you, it doesn't give you the correct answer, but it does give you a upper bound for the answer, because that's the biggest it could be is 1/2 times 7 times 12, which is 42. So any answer greater than 42 is too big. But that said, we want to be able to draw this triangle as is. So we're going to draw a line segment we're going to call RS. Okay. And that length is 7. Okay. R and S. That length is 7. Okay. Now, they also said ST, angle S is 33 degrees, and ST is 12. So 7. ST is 12. Now, 12 is actually quite long relative to the 7, and a 33-degree angle is kind of a shallow angle. Sorry, choice 2. I'm going to write right over you. I hope that one of you isn't the answer. Let's find out. So point T. I think it's an obtuse triangle. At least the way I drew it, it seems to be an obtuse triangle. Okay? Come on, make a straight side. There we go. Okay, so this is a 33-degree angle. Now, the reason, by the way, I gave you the advice of saying 1/2 times 7 times 12 as an estimate. It doesn't always give you the best estimate, but it does turn out that most of the time, it's better than you might suspect. And so, you know, we got an upper bound for the area, 42, and then we could decide if we think the answer is closer to 45 or closer to half of 45 or closer to 0 based on the diagram that we drew. And I do see that like a height of 12 would be pretty tall. That would make a pretty tall triangle. So this leaning to the side makes it quite small relative to 45. So I suspect that this one's wrong. Again, test taking strategy. But I want to do the calculation. There is a calculation. There's a formula for the area of a triangle given 2 sides and an included angle. Given sides A and B with included angle C. So included angle C means that you have 2 sides A and B, and the included angle is the angle that those 2 sides make. The non-included angle is another angle. So if 2 sides make an angle, the included angle is that angle. So the area of the triangle equals 1/2 AB sine C. So in this case, we have included angle S with sides RS and ST. So the area is equal to 1/2 RS times ST times the included angle, sine of the included angle, sine S. And so we could actually just plug into this formula. And so we get 1/2 RS 7 times ST 12 times the sine of S, sine of 33. And so what this gives us is the answer. I'm debating whether I should redo this problem actually without using the law of sines. I might. We'll see what happens. But this is, I'm sorry, this is not the law of sines. This is a precursor to the law of sines. Let's see, 1/2 times RS, which is 7, times 12. And you see that estimate, the 1/2, 7 times 12. But then there's a correction factor times the sine of 33. And that's approximately equal to 22.874. That's my alarm. 83947, which is approximately 22 point, the 8 and then the 7 rounds up to a 9. So that gives us this answer. Okay. I think I am going to do this one without using this area formula in case they didn't expect us to do it. So what I did is I kind of did my best to recopy the triangle up there. It doesn't look exactly the same, but again, this is hand drawn. And I extended RS horizontally, and then I drew a vertical down from T. I'm going to call this point P because now this is an altitude of triangle RST, which is perpendicular to RS. So if we actually get TP, we could use the area of 1/2 base times height, which is 1/2 RS times TP. But along with being an altitude of triangle RST, TP is also the leg opposite to angle S in right triangle PST. So triangle PST is a right triangle because we made an altitude perpendicular to the base. Automatically, it's a right angle. And also, TS is a hypotenuse to triangle PST. So we could use SOHCAHTOA again. And in this case, we have the opposite leg, TP, which we're looking for, and the hypotenuse 12, which we have, and we have the angle S. So we could use sine. So sine of 33 is equal to the opposite leg, TP, divided by the hypotenuse, TS. So sine of 33 is equal to TP over, mystery TP over known TS 12. Okay? Now, again, you could cross multiply, put the sine 33 over 1, and then cross multiply. I also like to at least acknowledge some algebra skill here. You could also multiply both sides by 12. And then you get TP is equal to 12 sine of 33, which again, we're going to get a decimal. And in fact, I actually know what decimal no, I don't know which decimal we're going to get because this is in length. TP is 12 sine 33. Now, that I press enter there. Now, am I gonna, I normally speaking, I would write down that entire value. And in fact, I think I will. But I don't have to in this case because I'm going to use my calculator and let that thing store the answer for me. So 6.535666842. And now I do that the area is 1/2 base times height is equal to 1/2 base times height, which is equal to 1/2 the base is RS. Remember, we're looking for triangle RST's area, not PST. We're looking for area triangle RST. So the base is RS and the height is TP. So that's equal to 1/2. RS is 7 and TP is that number, which I'm not going to have to rewrite because I'm going to let the calculator do that for me. So bring that up again, times 1/2 times 7. And we better get the same answer, 22.87 and change, and we do. This answer here. 22.87483947, which is approximately 22.9. Okay, so we did that problem 2 ways, just because I don't know if your teacher will be teaching this. It's a good formula to have, though. This is all the way at pre-calc that we really cover that one. It comes up very frequently. But let's move on to number 12. Okay, we're gonna have to zoom into this a little bit in a second, but first we got to be able to read it. So number 12, triangle ABC with vertices whose coordinates are A, -3, -2, B, -1, 2, and C, 4, 1 is graphed on the set of axes below. Sure, it is right there. Triangle A prime, B prime, C prime, whose vertices have coordinates A, -6, -2. Okay. B prime, -2, 2. Okay. And C prime equals 8, 1. Now you'll notice that I drew these pretty quickly. I have a pretty good eye for coordinates, but you should definitely be counting carefully. Okay. This is something you don't want to get wrong. You don't want to plot a point wrong accidentally. This triangle is the image of triangle ABC, the transformation that maps triangle ABC onto A prime, B prime, C prime is, okay, so we have that, to that, to that. Okay, so these triangles don't look congruent, not to me. Angle B looks just shy of a right angle, like 90 something degrees, maybe not even 100. Whereas B prime looks to be more than 135 degrees. C prime looks to be an angle like 10, 15 degrees. Angle C looks like a 30-degree angle. So does angle A prime. So these triangles are not congruent. So the answer to this, nor are they similar. The answer to this, because again, similarities preserve angles, because of this, it can't be a transformation that preserves similarity. Dilations preserve similarity, and translations also preserve similarity. So the question is this vertically stretched up and down or horizontally stretched left to right? And I mean, it looks horizontally stretched. And in fact, if I notice the x coordinate of B from -1 to -2 got multiplied by 2. The x coordinate of A got multiplied by 2. And the x coordinate of C also got multiplied by 2. That's a horizontal stretch by a factor of 2. Centered on the y-axis. So that's the answer to number 12. Number 13, which equation represents a line parallel to the line represented by y equals 4x plus 6 and passing through the point -3, 2? Is it y minus 2 equals 4 parentheses x plus 3? Or is it y plus 3 equals 4 parentheses x plus 2? Or is it y minus 2 equals -1/4 parentheses x plus 3? Or is it y plus 3 equals -1/4 x minus 2? And so this one's asking something slightly different from the other one. It's the question of whether it's not for this one. And by the way, this is a 2 by 2 problem again. Is this coefficient 4 or is the coefficient -1/4? and then the question about the coordinates. So we'll address the question about the coordinates in a moment. But the question about the slope, lines that are parallel lines have equal slope. And also, let's add this to a detail. For our learning, perpendicular lines have slopes that are opposite, meaning the negation, reciprocals of each other. And the opposite of 4 is -4. The reciprocal of -4 is -1/4. So in fact, these are perpendicular to the original line, making them both wrong because they have a slope of -1/4. So the answer is either choice 1 or choice 2. Now talking about again, this is a 2 by 2 problem. The question is, do we subtract 2 from y and add 3 to x, or do we add 3 to y and subtract 2 from x? And now this is the question. The previous one was asking whether we subtract the x coordinate or add the x coordinate, and whether we subtract the y coordinate or add the y coordinate of the center. Here, they're actually asking whether we know to transpose or not transpose the x coordinate and y coordinate with each other, and we don't transpose them. The x coordinate acts on x, the y coordinate acts on y. They both get subtracted. So the point slope form of a line with slope m passing through point h comma k, just like the center of the circle, is y minus k equals m parentheses x minus h. And so we have the y k is 2, so we got y minus 2 equals slope m 4 parentheses x minus -3, so also known as y minus 2 equals 4 parentheses x plus 3. Number 14, which two-dimensional figure is always formed when a plane intersects a right cylinder perpendicular to its base? Is it a circle, triangle, rhombus, or rectangle? Now this is a two-dimensional figure when a plane intersects a right cylinder perpendicular to its base. So let's talk about what that is. First off, if you have a right cylinder, you have something along these lines. Okay, you have a right cylinder. That's what a right cylinder is. Now, notice that if you cut anything perpendicular to anything, or cut through this thing at all, you're either going to get rounded edges or you're not, right? But if you don't get rounded edges, that means you're cutting vertically. There's no way to get a rhombus that's just guaranteed to be a rhombus without right angles. And there's no way to get a triangle out of this at all because of the circular edges. So a circular edge doesn't, or rather a triangle doesn't make sense. But if we look at the circle, rhombus or rectangle, again, a rhombus doesn't quite make sense because there's no way to get a rhombus because of the curved edges, unless you go vertically, and then in case you might get a coincidental square. But let's talk about what it means perpendicular to the base. If you go parallel to the base, that means since the base is flat for us, a plane parallel to the base is a plane cutting this way, and so then a plane perpendicular to the base is going this way. So if we imagine this is maybe I don't know, pepperoni, or let's make it like salami or something like that, because we could get a thick round slice, or maybe a round stick of butter, which you can find, you can imagine that, or a round hunk of cheese. Then you cut vertically. Okay, when you cut vertically, you're going to get a straight cut across somewhere along the top, let's say there, okay? And then, but when you're cutting vertically, you're going to get a cut straight down also, okay? And those are going to be right angles. So already this rectangle is looking good. And then when we get to the bottom, well, we get that bottom edge, and these are also right angles. Okay? So you do get, in fact, a rectangle here. If you were to cut horizontally, you would get a circle. And if you were to cut at a diagonal, you'd get an ellipse or part of an ellipse, perhaps a truncated ellipse. Number 15, in triangle KMP below, CE is drawn parallel to MP. Sure looks parallel. Okay. Then if KC is 8, that's 8 right here. And CM is 3, that looks legit. Let's actually make this more accurate. There. Then CM is 3, that looks legit too. What is the length of MP? Oh, I'm sorry. I was like, that's not enough information. Then CE is 12. There we go. 12. And then, so then what is the length of MP? Is it 24, 16.5, 15, or 4.5? Clearly, MP is longer than CE, so we're just going to cross out the 4.5 right away. But also, this figure is drawn to scale because the 3 is bigger than the, it's smaller than the 8 and less than half of the 8. So, and then the 12 looks about 1.5 times the 8. And it looks comparable in size to the 11. So yeah, MP is got to be close in size to 12, meaning 15 and 16.5 makes sense, and 24 is entirely too big and too small for the 4.5. So how do we do this problem though? This problem that is done by recognizing since these two sides are parallel, they form congruent angles, and the vertex angle K of the two triangles that are formed, well, it's congruent to itself by the reflexive property. So the two triangles formed are similar. So triangle KCE is similar to triangle KMP by the angle postulate. And so we could do proportions of corresponding sides. KC, which is known, over CE, which is known, is equal to KM, which is also known, 11, over MP, which is unknown. So let's put the numbers that we know in. 8 over 12 equals 11 over MP. We now do the cross multiplication that we've done once in this test, but could do many times. And 8 MP equals 12 times 11, divide by 8, divide by 8. And then the calculator tells us that MP is equal to, 1.5 times 11 is 11 plus 5.5, or the calculator 16.5. Now, number 16, a parallelogram must be a rectangle if its diagonals are perpendicular, or bisect each other, or bisect its angles, or are congruent. Let's see. So this tells us that it is a parallelogram, but what's going to force it to be a rectangle? Okay, as opposed to just a parallelogram. Let's see. Nice, it drew a parallelogram. Good. So if the diagonals are perpendicular, so these diagonals are almost perpendicular, but we could actually, but look at this. These diagonals are not perpendicular. So it's unlikely that perpendicular is the answer. And in fact, if it's a rhombus, if it's a parallelogram with, there we go, with perpendicular diagonals, that makes it a rhombus. Okay? That makes it a rhombus. So a rhombus is a parallelogram with perpendicular diagonals. So that's not it. Now, do the diagonals bisect each other? Well, in a rectangle, sure they do, but actually they just bisect each other in a parallelogram. So number one, choice one says that this is a rhombus, and this is bisecting each other is already true about parallelograms. So that's not it. Then the next one, bisect its angles. So if the diagonals of a parallelogram bisect its angles, then it's actually a rhombus. But if they're congruent, if the diagonals are congruent, that does make it a rectangle. And in fact, and you could prove that in a few ways. But you you can prove that, for example, that the figure that one triangle is congruent to another triangle, making the two angles congruent, and then you could prove that this thing is a parallelogram, making the two angles supplementary. So now you'd have supplementary congruent angles, making it a rectangle. So that is being the diagonals being congruent is enough to prove that the parallelogram is a rhombus. Rectangle. Sorry, let me restate that. The parallelogram with congruent diagonals must be a rectangle. Number 17 points O divides COA such that CO to OA is 1 to 4. If C has coordinates -2, -9, and A has coordinates 3, 6, the coordinates of O are 2, 3, 1, 0, 0, -3, or -1, 6. Now, I was going to draw a rough graph, and in fact, that's what I did on my paper, but we should actually take this to the end of the test. Now, I did record my numbers on a scrap piece of paper, but luckily, if you have, if you're working on a paper test, then you could actually flip back and forth. Let's actually make this graph. Let's make this with, I'm going to change my color to magenta. It's actually a much more colorblind friendly version of red. Okay, so we have that. Wow, it's actually better to not have it draw the perfectly straight line. Let's try this again. Okay. Let's draw the horizontal. I don't know why when it draws the straight line, it makes it so thin. I wish it kind of didn't. Okay. Now, the points are -2, -9. So -2, -4, -6, -8, and then keep going to -9. -2, -9, that's point C. And then -2, -9. And then point A is 3, 6, so 3. And then 2, 4, 6. So point A is there. Now I'm going to draw a line segment CA. Okay. And then I remember that CO to OA is equal to 1 to 4. Okay. So I know that O is closer to C. So if I just use that to eliminate choices, I could probably eliminate a lot of choices. I can't scroll up right now to see which ones would be eliminated just by stating that O is closer to C than to A. But I'm going to do the math over here. CO to OA is 1 to 4. So if I had to split this line segment up into 5 equal parts, I mean 1, 2, 3, 4, 5. So I could actually just, since it's not a part 2 question, I could actually just state that that's the answer. But I need a way to do that calculation. Okay? X, Y. Okay? I'm not going to use XY because that's too generic. How about AB? So let's go back to the problem. It's number 17. So, and again, we said that the point has to be closer to C, and by a lot, in fact. And so we basically got the answer right already. But if the midpoint of if the coordinates of O are A comma B. No, do I want to use A comma B? You know, I'm gonna go back and use the X comma Y that I was gonna use. X comma Y. Then I could actually use the proportion CO to OA. Because the distance from C to O in the X direction is X minus -2. This is the distance, the horizontal distance to from X to O, from C to O. And then divided by the horizontal distance from O to A. So the X coordinate 3 minus the X coordinate generic X. This is equal to a ratio 1 to 4. And we could actually cross multiply now. Now we got our algebra game going. Let's actually cross multiply. So we got 4 parentheses X minus -2, so X plus 2 parentheses equals 1 parentheses 3 minus X. Let's distribute, good old distributive property. 4X plus 8 equals 3 minus X. And then let's see, we're going to run out of space here, so we're going to take up some real estate on 18 probably. But plus X, and minus 8, and we get that 5X is equal to -5, and divide by 5, and we get that X is equal to -1. And so we got the X coordinate, and we do the same math to get the Y coordinate if this were a part 2 question. So you would do, to get the Y coordinate in a part 2 question, you would do Y minus the Y coordinate of C, so Y minus -9 over the Y coordinates of A and O subtracted 6 minus Y is equal to the same ratio, 1 over 4. Solve that one by cross multiplication. You would get -6 for Y. But number 18, a spherical balloon is fully inflated with helium to a diameter of 1.7 feet. If helium costs 80 cents per cubic foot, what is the cost to completely fill the balloon with helium? So we should probably check the test to see if there's a formula for the volume of a sphere, and conveniently there is. V equals 4/3 pi r cubed. V equals 4/3 pi r cubed. Now, this might be obvious to some kids, especially if you're hitting 90s on your test, but it's not obvious to all kids. So I'm just gonna say it. When a formula has certain variables in it, you are not allowed to just substitute one variable for another. Like pretend that the variable is something other than what it actually is. That formula has a V and an R in it. If you don't use a V and an R, a volume and a radius, you just did it wrong. They did not give us the radius, they gave us the diameter, and so we need the radius for this formula. So since the diameter is equal to 2r, we have that 1.7 feet is equal to 2r. Divide by 2, and we get that r is equal to 1.7 divided by 2, which is let's see, 0.5 plus 0.35 is 0.85 feet. And then we plug that into the formula for the volume. V, because that's definitely going to be relevant for us because helium takes up a certain amount of volume. 4/3 pi 0.85 cubed. And we got to let the calculator do that. Let's see. 4/3 times pi times 0.85 cubed, and you know how I like to do to write the full number. V is approximately 2.572440.785. Not that we're going to use that number necessarily. And now they said that helium costs 80 cents per cubic foot. So thinking about it the way we did before. So 1 cubic foot, 80 cents. 2 cubic feet, 280 and 80. 3 cubic feet, 80 cents, 80 cents. 4 cubic feet, 80, 80, 80, 80. In other words, the number of total price is equal to the 80 cents times the number of cubic feet. So the cost is equal to the volume, the number of cubic feet, times the 0.80. So that's equal to that number times 0.80. We're going to let the calculator store the number for us. Let's get the calculator out. Times 0.80. And we get this number. 2.05795 2628. 2628. That's, I write the full number for test taking strategy reasons and only that. And it's approximately equal to 2.0, and then the 5 rounds up to a 6. And that's choice 1. By the way, before I even get to number 19, I've been saying it on most of my videos now, and I'm gonna try to remember to say this on every video. I'm actually little offer for people who are watching really carefully. If you see me make a mathematical mistake, it's got to be a mathematical mistake or an actual mistake on the calculations, and it's got to be a mistake that I do not catch, like I don't fix on the video. If I make a mistake and you're the first person to mention it in the notes, let me know, and you get a free 1 hour of tutoring from me specifically. And it's got to be in a topic that I tutor. So math, physics. If I'm begged, I could do chemistry. But math at all levels, chemistry and physics, I could definitely tutor. So if you catch me making an error that I personally don't catch, okay, and I don't fix in the video, if you're the first person to point out that error, you can, and you claim the hour of free tutoring, you can let me know. I'll get your information, and then we can do that hour, okay? But it's got to be a mathematical mistake that I don't catch, or it's a conceptual error or a calculation error that I don't catch, and that's true for every video that I do. Okay. That said, I got the cost 2.06, and I did confirm that that answer is correct. So that's not one of my errors. Number 19, in right triangle ABD below, does look like a right triangle, good. Altitude BC is drawn to hypotenuse AD. Okay, yeah, looks perpendicular. It's an altitude, so that's perpendicular. They also said that AC is 2.5 and CD is 4.3. They sure look like that relative to each other. What is the length of BA to the nearest tenth? To the nearest tenth. If I did guessing, that one's looking good to me. If I assume drawn to scale, but in fact, I actually confirmed drawn to scale, because double 2.5 is 5, and this is slightly less than double. CD is slightly less than double AC, and all the right angles look like right angles. This thing is drawn to scale. So 4.1 is looking mighty fine to me. 5.4 is looking too big. 3.4 is looking too small, and 3.3 is looking too small. So I suspect the answer is choice 3. Let's see if I'm right. Remember, the other one I got wrong when I guessed, but it was because it was within 5 degrees of each other, right? The answers were so close to each other that they were tough to get. Fun fact about test taking strategy. They used to give answers that were close to each other to eliminate or reduce the ability of students to guess based on size. But they actually moved away from that for really good reasons. They moved towards putting answers on the regents that students could get via incorrect mathematics. So what ends up happening is, if the student does something wrong, they're more likely to get an answer that does appear. So maybe they put numbers in the wrong place, and the answer appears just as they did it. the problem with putting just random numbers that can't be arrived at via incorrect methods is that the only students who that tests against is students who guess based on size. And that's just almost no one. And it's also not mathematical. You're not really testing math at that point. So all the answers that they give really can be arrived at via some incorrect method, which actually is a benefit, because what that does is it makes it so that answers that are wrong are more likely to be very wrong. And if you notice in the one where I guessed actually incorrectly, but two of the answers were 5 degrees apart, which was pretty close. The other answers were like half or double, or close to half or close to double the correct answer. Sometimes the answers are going to be like wildly different. Like, get an angle that's almost 90 when the angle's tiny acute, or get an angle that's like 12 degrees when the angle's actually an obtuse angle, or something like that. So yeah, anyway, so in this case, this diagram's drawn to scale, so 4.1 is looking mighty fine, even if I don't know how to do this one. But how do I do this one? When you drop a vertical from the right angle to the opposite side, an altitude rather, from the right angle to the opposite side, you form 3 similar right triangles. And the angle correspondence is, well, I'm going to do the outside triangle, BAD, triangle BAD, is congruent to triangle. Now the left side triangle has a right angle at C. Now suppose I don't know which vertex corresponds to A, B, or D, A or D in the outside triangle. Well, I do know that A corresponds to A because by the reflexive property. So the next angle is A. And therefore the third angle has got to be the one that corresponds to D. Similarly, I'm going to move this over a little bit. Similarly, I'm going to make a congruence relation for the right side triangle. Angle C is the right triangle. And then now I see that angle D has to correspond with angle D of the outside triangle. So I'm going to leave a gap and then put a D. And then the middle vertex then has to be that top vertex of the right side triangle, B. So now I have the congruence relation in the correct order. So the first vertex corresponds to each other. The first vertices correspond to each other. The second vertices, A, and B, correspond to each other. And the third vertices, D, B, and D, correspond to each other. Now, I see, let's see. They're asking for BA. I'm going to call this side X. Now, X, actually, I'm not going to call it X because I could just call it BA. BA is the hypotenuse of the left side triangle and it's also a leg of the outside triangle. So I'm going to make a ratio with the hypotenuse and the leg of the outside triangle. Let's see. So I see that BA, the hypotenuse of the outside triangle, AD, over the hypotenuse of the left side triangle, AB, is equal to, well, that small side of the outside triangle, AB. Now I have to see which side that corresponds to on the left side triangle. So AB are the first and second vertices of the left side triangle. So it's got to correspond to the first and second vertices of the left side triangle, CA. CA. And so now I could put in some numbers. Let's see. AD, well, AD is equal to AC plus CD. So AD is equal to 2.5 plus 4.3, which is equal to, let's see, 6.8. So we got 6.8 over AB, which is an unknown, AB, but it's okay that it's unknown because we're looking for it, equals the same AB over CA, which is known, 2.5. And we could do some nice cross multiplication. Now we have the square of AB. AB squared is equal to 6.8 times 2.5. And we could take the square root, bring in the plus or minus, and we reject the minus because the length of AB is greater than 0. So that AB is equal to the square root of 6.8 times 2.5. I'm going to let the calculator sort that out for me. Square root of 6.8 times 2.5. And you get 4. You know how I do, put the full digits. 4.123105626, rounded to the nearest tenth. It's approximately 4. Now the 2 causes the 1 to round down, to stay the same. 4.1, which is exactly the one that I personally had suspected. So I guessed right on this one based on scale. And I was actually pretty sure of that one. And hey, problem 18 actually, which was 2 problems ago, secured us a passing grade on this Regents. So we officially have passed this Regents. Can we pass this Regents by focusing on the multiple choice questions? Yeah, but I want to point something out. This Regents, let's go to the conversion chart. To get a 65, we needed 35. Now, in most Algebra 1 Regents, you actually need like, Geometry Regents, or most math Regents, you tend to need closer to like half the multiple choice, so like 24, 25, 26 problems. But clearly they've modified the conversion chart now so that we need 35. Now, do I still call a passing problem a problem where we eliminated 2 multiple choices? Absolutely. And I've given you some process of elimination methods. And some of those can be expanded to eliminate all the incorrect choices. That said, we need a few more points than just half the multiple choices. So what does that imply for us? What that implies for us is that we can't just do the multiple choices without showing work. It's not going to work out for you if you've been trying to do that. If for example, you failed geometry last year, the Regents, and you're just trying to take it again, but you have been, look, I need you to be humble, because the truth is that students who don't show work tend to not show work because they choose not to show work. So I just need you to be humble for a moment, and understand that from now until the point where you take the Regents, you just have to show work. There's really no way of actually passing the Regents, really, I think, without showing work. And I have had students who literally failed the Regents, came to me, and I've been tutoring, and I tutor for a pretty good fee. I'm actually pretty good at teaching and tutoring geometry. And the truth is, I've had students who have come to my class, attend my class for the full year, and get 1 point less on the next Regents. Why? Because no matter how much I taught them, every time I said, you got to show work, you got to learn how to show work, you got to show the actual operations, they actually use that as a reason to refuse to show work. So I need you to be humble and show your work. Okay? That said, this is our snack time. If you need to use the restroom, get a snack yourself, keep the video playing, go ahead. This snack time portion is going to be much shorter than my usual snack time portion. My usual recommendations, I would love to be sponsored by one of these companies, but I am not. I literally, so because I'm not, I could talk about these products in a positive way without worrying about being sued. Fairlife milk, just nice 11.5 ounces of fluid. Won't make you have to run to the bathroom because of too many fluids. And because it has a lot of protein, it'll make you feel more full. So it's nice, and it has a little bit of carbs and a little bit of fats, very small amount. So it's not the best for giving you energy, but it doesn't take away your energy either. A pure protein bar is a good choice for a quick snack. It makes you chew slowly, so it helps you take away your hunger a lot better. It's got a lot of protein. It doesn't make you run to the bathroom usually. It's got 18 grams of carbs and 5 grams of fat. So in terms of the carbs, it's not the healthy, but we're not trying to, don't sue me, pure protein. But it's not, and it is worth noting, that dietary fibers to total sugars is actually just 3. So it's actually not that bad. Sugar alcohol is 5. So the total carbs is 18, but the number of total sugars is 3. Whatever that means. Whatever that means. But the protein is 20. But again, we're not trying to be eat the snacks for healthfulness. We're trying to eat the snacks for maximizing our test grade. That's the only thing that we care about. So I do recommend for that, like a pure protein bar. Another thing I recommend is like mixed nuts, your favorite brand of mixed nuts. I recommend not something messy. But yeah, mixed nuts if you're not allergic to nuts. One thing I discovered recently, pralines. Pralines um, are covered in like a milky, sugary thing. So if you're not lactose intolerant, they might not bother you. Um, uh, and they give a lot of energy because they have actually a bit of sugar on them, and they have fats and a little bit of protein to fill you up. So I do recommend those. That's the full snack time. If you still need some time to use the restroom and get your snacks, please do take the time. I'm taking my time and I'm sipping on this, but I'm sipping on this periodically. You may see me sipping on this while I'm videotaping, and you might not. Where's my mouse? I don't know why my mouse just disappeared while I was talking. Maybe I should contact Fairlife and ask them to sponsor me. Why not, right? Number 20, trapezoid ZOYD has parallel sides ZO and DY. If the measure of angle Z is 141 and the measure of angle Y is 73 degrees, what is the measure of angle D? Is it 39, 73, 107, or 141? Based on just the reading, I don't know. I have to draw a diagram. So I know it's a trapezoid, so it's got one pair of parallel sides, and it tells us which sides are parallel, ZO and DY. And it also says the measure of angle Z is 141. So I'm going to make Z on top. Okay. Why does that make that an arrow? I don't want it to be an arrow. This time I actually really don't want it to be an arrow. By the way, any minor mistakes like that, I'm going to keep in the video because it's just too much editing time. And I know a lot of students requested a lot of videos. And I noticed that I was spending so much time doing the editing. And I was just like not putting out videos. And so like I would do like 2 regents and then spend like 5 times that much time just removing sneezes, removing coughs, removing removing uhs, every every that's another cut. And I say and all the time. So a few hundred times for each. That was a lot of editing. And then so I would do 2 videos and then edit each one for like 20 hours. Not worth my time. So I'm not going to cut out the not going to cut out the uhs. I'm not going to cut out little minor edits that I have to do from like the screen jumping. Anyway, so going back to this problem, ZO and DY are the parallel sides. The measure of angle Z is 141, which is a quite obtuse angle. So I'm going to do it like that. Z, 141 degrees. And now it's got a parallel side. And I see, let's see. They said the measure of angle Y is 73 degrees. So ZO, so this point is O. And so Y is not that angle. And it has to go in order. So it has to go ZOYD. So because of the name ZOYD. So Y has to be one of these bottom ones. I'm just going to move this over slightly there so I can make it look like a 73-degree angle. Let's see, like there. It doesn't have to be so perfectly perfect, you know. Oops. But I want it to be close. So that's point Y. This is 73. And then they want to know the measure of angle D. Now, if you trust my diagram, D looks like a very acute angle. So this angle is looking nice, and the other ones are not looking so nice. So I think those are wrong. In fact, I could pretty much confirm that this and this is wrong, because D is not going to be an obtuse angle, because Z is an obtuse angle. But what is the theorem that allows me to answer this question? these are parallel sides, and because they're parallel sides, these angle Z and angle D are same side interior angles. Angle Z and angle D are same side interior angles. And what does that mean in terms of calculations? That means that they are supplementary. So the measure of angle Z plus the measure of angle D is equal to 180. So I got that 141 plus the measure of angle D is equal to 180. Subtract the 141. Subtract the 141, and I get the exact answer that I suspected, that the measure of angle D is equal to 39 degrees. On that note, we go to number 21. That triangle ABC is translated 5 units to the left and 2 units up to map onto triangle PQR. Which statement is not always true? Is it that triangle PQR is congruent to triangle ABC, or that angle A is congruent to angle Q? Or is it that BQ is radical 29? Or is it that RQ is equal to CB? Which statement is not always true? So let's see. So we talked about that the vertices as written, they have to be written in the correct corresponding order. That's actually part of the requirements of the writing. Fun fact, have I seen them make an error by like writing it in just slightly the wrong order? Yes. And I actually have seen them do that and not send out a correction and, you know, like make it so that everyone who read that problem got it right. The reason why is because even though they made a mistake, it wasn't the most vital answer changing mistake. I disagree with that. I think if they typed it wrong, they should give everyone the points for it, but that's a long while ago, and it's been they used to do it every like other year. Now I haven't seen that error in a while. So that said, angle A has to correspond to angle P. Angle B has to correspond to angle Q, and then angle angle C. Oops, oh, different color. Angle C has to correspond to angle R. So when they said in choice 2, I noticed that I immediately gravitated towards choice 2 because they said angle A corresponds to angle Q, or is congruent to angle Q. But I noticed those are 2 different colors. And specifically, angle A is the first vertex. Angle Q of the first triangle. Angle Q is the second vertex of the second triangle. They're not necessarily congruent. Remember, not always true. No. This is definitely true because the translation preserves congruence, but this, and of course RQ, third and second vertex, CB, third and second vertex, this is true. And so the surprising one maybe is this is the harder one to tell, but then if you graph it and confirm by the Pythagorean theorem, radical 5 squared plus 2 squared is radical 29. So that's so the answer to this one anyway is choice 2. Again, here, radical 5 squared plus 2 squared, and here RC, R and C, and then Q and B. Q and B, the colors match, so the congruence relation is true. And the order of these vertices are correct. Okay, let's hop to number 22. Okay, so in the diagram below, congruent triangles PEN and PAL are drawn. Which rigid motion maps PEN onto PAL? Is it a point reflection of PEN through P, or is it a reflection of PEN over the angle bisector of EPA, or is it a rotation of triangle PEN about point P mapping PE to PA, or is it a translation of PEN along EA mapping point E onto point A? Okay, so there's some that we can eliminate. First off, these are not arranged, or these do not look like identical copies of each other that can be slid one onto the other. So the translation, and translation preserves parallelism, so the translation can't be it. The next thing I noticed though, PEN, I'm going to draw the corresponding vertices because of the ordering. PEN, first, second, third, PAL, first, second, third, A and L. And here I'll draw the first, second, third, EN. And so what do I notice here? I'm going to draw these in a different color. EN. I notice that if I rate the vertices of PEN in that order, PEN is a counterclockwise orientation. Counterclockwise orientation, meaning I go around the vertices in that order, counterclockwise orientation. Whereas PAL goes from P down to A to L, back to P. That goes in a circle the other way around, right? In a clockwise orientation. So these have opposite orientations. One has counterclockwise orientation, the other one has clockwise orientation, which means that rotation will not preserve, a rotation will not be the answer because a rotation preserves orientation. Another way you can argue that this is not it is that if you rotate PE onto PA, then N is going to be somewhere out here, not over L, right? So that's not it. Another one then, this one, the point reflection of PEN through P would mean that L gets reflected all the way out to here. A gets reflected straight through to like somewhere here. Not onto E and N. So what about a reflection of PEN over the angle bisector? Actually, that's it. So there's a line of reflection that can be created by either the perpendicular bisector of EA or the angle bisector of EPA. And that's actually how they chose to do it. The angle bisector. There we go. Which happens to be a vertical line. Okay. And if you reflect over that line, then A gets reflected to E, and L gets reflected to N. Okay, so it is a reflection over that line. Number 23, in a cone has a height of 8 inches and a volume of 75.4 cubic inches. What is the diameter of the cone to the nearest inch? Is it 9, 2, 3, or 6? And I would say, is this formula in the back of the answer book? If this is a cone, let's find out. Cone, formula for the area of a cone. Here it is, 1/3 base times height. Volume equals 1/3 base times height, where B is the area of the base. Cones and pyramids are actually both pyramidal shapes. So they have the same formula of the base, of the volume, 1/3 base times height. In fact, any pyramidal shape has the same formula for the volume, 1/3 base times height. Just like any prismal shape has a formula base times height. Anyway, the volume formula, base times height. Anyway, so for this is a cone of height 8 inches and a volume of 75.4 inches. So let's make it a right cone, might as well, because it could be, right? It could be a not right cone, but since it could be any cone with these properties, let's choose a cone that has these properties. Now, this is not necessarily drawn to scale. There you go. Will it draw an ellipse that way? Oh, it did. Good. So if we draw the altitude here, H, and then the volume is 1/3 base times height, which they said B is the area of the base, and this is a cone, so it has a circular base. Let's put that in black, maybe. That was not black. It's also not straight, but okay, R. So 1/3, the area of the base is the area of a circle, pi r squared h. Okay, and let's put some numbers in here. Okay, that's V again. So the V is 75.4. That's equal to 1/3 pi times the radius squared times the height. The height is 8. Now, I'm gonna calculate the coefficients on the calculator because I'm allowed, right? They want us to the nearest inch, so I'm allowed. So it's r squared times 1/3 pi times 8. It's going to be a number close to 8 itself. 1/3 times pi times 8, okay, is equal to that number. And so I'm actually not going to write the number down here because now I could divide by 1/3 pi times 8 by 1/3 pi times 8, which I have that number on the calculator already. So that r squared is equal to the 75.4 divided by 1/3 pi times 8, which is what the answer that I just got is. Let's move the calculator over again. And honestly, wow, that's actually a really close answer. Really close to a whole number, 9-ish, right? So we're gonna, when we got a round, we know that we got a round. I'm actually just gonna round right now. R squared is around 9.000 and some other decimals. In this case, I'm just gonna keep it that because r squared is around 9. So when I take the square root, I get the plus or minus. Again, I reject the minus because r is greater than 0. So I get r is equal to the square root of 9, which is 3. And fun fact, if you notice that I just had to do a quick pause in the video, or like I just did a quick jump in the video, I made a quick edit because I just made a note that I got caught at exactly the same place that a lot of students get caught. They do all this amazing math and then they forget that the problem asks for the diameter. And they're not tricking you when they do that. That's actually a big point in geometry. Like they give you a small number of details and it turns out that unlike algebra or algebra 2, it turns out that you can go really, really far with those details. So the question is, how far do they want you to go? And on problem 23 out of 24 multiple choices, they probably expect you to go pretty far. We did a lot of work to finally get to R. And then finally, I almost got the answer wrong because I have to get the diameter. D is equal to 2R, which is equal to 2 times 3, which is equal to 6. The diameter is 6. I almost got caught on that. Diameter is 6, choice 4. Now, just check my answers. Number 24, the line represented by the equation 5x minus 2y equals 10 is transformed by a dilation centered at 2, 0 with a scale factor of 2. The image of the line is the original line. The image of the line is the original line, or passes through the point 4, 0, or passes through the point 0, negative 10, or is perpendicular to the original line. Now let's just be clear. Dilations preserve parallelism. If the original line was like that, sloped, the new line will be, however it's located, however it happens to be located, exactly the same slope. It'll be like that, same slope. So dilations preserve parallelism. So perpendicular to the original line is definitely not going to be it because it is a dilation. But they love asking this question, and they'll often do a dilation of a line centered somewhere. Sometimes it's a point on the line, which means that you dilate and you get right back to the original line, or you dilate out from another point and then you get a line that's twice as far. So here, I am going to do a rough graph. So 5x plus 2y equals 10. So if y is 0, x is 2. And if x is 0, y is negative 5. And you get a line that looks like that. Okay, let's confirm. Negative 5 times negative 2 is 10 with a 0 for x. And if y is 0, 5 times 2 is 10. Okay. I had to just quick check my answer. Now this is dilated by, it's a dilation by a factor of 2 centered at 2, 0. Here's the point 2, 0. right? Dilated through that point. When you dilate a line through a point on the line, there you go. It's going to preserve the line. So the dilation is the original line before even addressing any of the other ones. It is the original line because it's a dilation through a point on the line. If it's, and that's again, that they love asking that question. They either, almost always, they'll make you either dilate through a point on the line, in which case it preserves the line, or they'll make you dilate around over the origin by a certain factor, in which case it doesn't preserve the line, but it makes it twice as far from the origin. Can they ask you a dilation over a point that's literally any other point in the plane, like not on the line, but also not the origin? Yes, they can. But I just haven't seen it yet. So take that as you will. And we just got a perfect part one. We got a perfect part one. I actually am curious what grade we have now. 24 questions, absolutely correct. We got 48 raw score points. Let's see what we got. 73. So this might be disappointing to you. And by the way, 49 points, also a 73. But this might be disappointing, but there's an object lesson here. There's an object lesson here. We just got a perfect grade on the part ones, and we only have a 73. So if you remember, I said you should be showing work on the part ones. In fact, that showing the work on the part ones allows you to show work on the part twos, because the methods on the part ones are identical to the methods on the part twos. And notice, if you just refuse to show work, and you also, well, if you refuse to show work, then you're not going to get much credit on the part twos through fours at all, because you're not showing work. You're required to do work, and you're not going to get the answers, most likely. So you're not going to get that many points. So you got to show work. And notice, if you're only focusing on the multiple choice, you're not playing a game of 65 to 100. Or 0 to 100. You're playing a game of 0 to 73. And you're trying to pass with a 65. 8 points away from passing is the best grade you can get if you only focus on a multiple choice. That said, you'll notice as we do the part twos look like a part one question, just without multiple choices. So the methods that you use when focusing on the part ones, which is the methods, then is the same things that you would do in the part twos. And there's a couple of big deals in the instructions. First off, the third of 5 times that they say it, not necessarily drawn to scale, almost definitely. If in Algebra 1 and Algebra 2, same deal, except that in Algebra 1 and Algebra 2, almost always the diagrams are actually just required to be drawn to scale, which is rare. Not as likely for geometry. Anyway, so the next part here that I love pointing out is that a correct numerical answer with no work shown will receive only 1 credit. So if you happen to know how to do the problem on your calculator, for example, but you have no clue how to do it via correct math on paper, get the answer, write the answer down, move on, you get a point. If you don't know how to do the problem at all, and you don't know how to do it on the calculator either, but you get an estimate and you improve on the estimate and you just keep improving on the estimate, however, with using correct math, you may find that your guess is correct. I've seen students do things like, well, this angle based on, scale has to be slightly bigger than 60 degrees, less than 70 degrees, if they're assuming drawn to scale or they confirm drawn to scale. And then they guess an angle that's just the right size. And like within a couple of degrees, they just guess a number and they have a bigger chance of getting it right. So if you know how to get an answer correctly, even if you don't know how to do it there, like on a paper way, get it. That said, most likely, if you just write down what you did on the calculator on paper, that's enough. And fun fact, if you write what you did on the calculator on paper, but then you get the wrong answer, the grader might be able to interpret your work as either a conceptual error or a calculation, or a conceptual error or an arithmetic error, or algebraic error. And instead of taking off 2 points, they might take off 1 point, even if you get it wrong. So write down what you did on the calculator. Okay, that's enough advice. Let's go to number 25. In the year 2020, the village of Depew, New York, had an area of 5.1 square miles and a population of 15,069. In the same year, the village of Lancaster, New York, had an area of 2.7 square miles and a population of 10,087. Which village had the larger population density in 2020? Justify your answer. So population density means population per unit area. So population density equals population per unit area. And it's worth noting that this definition, when you say something per something, that actually also gives you the formula. Let's call this letter D. The density is equal to, the per is a division. So it's the population divided by the area. So the density of Depew is equal to its population, 15069, divided by 5.1. And now, do I have to give units? They only want us to compare the population density. So as long as we're using the same units, we don't have to put them. And the second thing is, if they give us the units, then we don't have to give the units. Now, I did look at the solution set, and I did confirm that in this case, you do not need the answers, the units. So let's put these numbers into the calculator. Let's see where the calculator is located. Let's move this over a little bit. And let's put the numbers here. So 15069 divided by 5.1. Okay. And so I'm going to write the numbers. It's going to be blocked off for a second. Well, no, let me just put it here. 2954.7058882. Okay. And then the population density of Lancaster is equal to, again, the population over the area. So 10,087 divided by the area, 2.7, which is equal to, let's get the calculator going again, 10,087 divided by 2.7. I think this is going to be a bigger number. 2.7 equals 3735.925926. And now we could say which village had the higher population density. Justify your answer. Justify your answer means show the calculation. We did the calculation, and our variables are clear what they mean. And the density of Lancaster, the population density of Lancaster is, what's that, capital O, is greater. Number 26, in triangle ABC below, AC is extended through CD, yep, looks like it, to D. Measure of angle A is 3x minus 22 degrees, and the measure of angle B is 4x minus 18 degrees. And the measure of angle BCD is 6x minus 23 degrees. And determine and state the measure of angle ACB. So there's a couple of ways that I could do this problem. For example, I could use the fact that the sum of the measures of the angles in a triangle is 180, right? So that this angle measure, angle CAB, plus the measure of angle A plus the measure of angle B is 180. To get a measure of angle ACB, did I speak that right? Hold on. The measure of angle ACB plus the measure of angle A plus the measure of angle B is 180, which gives me a way to calculate the measure of angle C in terms of 180, this A and this B. So I can get C in terms of X. Then angle ACB and angle DCB would be supplementary. And that gives me an equation that the sum of the angle measures ACB plus DCB adds up to 180. Great. Except I'm going to do this a different way, because there's something called the high school exterior angle theorem. And it's called that because high school tests tend to be like pretty obsessed with it. In fact, the Regents has recently not been quite as obsessed with it, but clearly in this new Regents they're bringing it back, so they're kind of obsessed. And what is the high school exterior angle theorem? The high school, again, high school exterior angle theorem. Okay, so what does it say? In a triangle, the sum of the measures of two interior angles is equal to the measure of the opposite exterior angle. So if you notice, angle A and angle B are two interior angles whose measures are 3x minus 22 and 4x minus 18, and they are opposite to the exterior angle DCB. So the measure of angle A plus the measure of angle B plus the measure of angle B, according to this high school exterior angle theorem, is the measure of the exterior angle on the opposite side, the measure of angle DCB. And we put variables to that now. And so we get the measure of angle A is 3x minus 22 plus the measure of angle B is 4x minus 18. And that's equal to the measure of angle DCB, which is 6x minus 23. And now let's actually just do some quick math. Let's see. Let's make sure we don't do any illegal math. So I get I can combine the x's. 3x plus 4x is 7x. And I can combine the subtraction. Minus 22 and minus 18 is the same thing as minus 40, is equal to 6x minus 23. I'm going to subtract 6x, and I'm going to add 40 at the same time. You don't have to add 40 at the same time, but you are allowed. And we get that x is equal to, let's see, negative 23 plus 40 is 40 minus 23 is 17. Okay? And you could check to see if this diagram is drawn to scale at this point. Just for fun and just for a check. But I'm gonna but when we talked about guessing, if you assume that it's drawn to scale, you just guess at what you think. What are we looking for? The measure of angle ACB is the measure of angle ACB. So we're looking for this interior angle, right? So if you just guess any number, like it looks slightly above 90, any angle measure above 90, then you might get lucky and get it right if you just throw the number out there. But I'm going to actually use X now. The measure of angle DCB is equal to 6x minus 23. And by the way, I did mentally check if it is drawn to scale, and it is. So 6x minus 23 is 6 times 17 minus 23, which is equal to, I'm gonna let the calculator do the arithmetic for me. Oops, let's move this to the side a little bit. 6 times 17 minus 23. 6 times 17 minus 23. 79 degrees. And so then the measure, and then we said that the measure that ACB and DCB are supplementary. So the measure of angle ACB, which is the angle that they want, is equal to 180 minus the supplement of that angle, the measure of angle DCB. So it's equal to 180 minus 79, which is equal to a number slightly bigger than 90, is 101 degrees. If you had guessed, you might have gotten lucky. I actually do advise, by the way, to do that kind of guessing. It's not a bad strategy. Um, it's not the best, of course, but but it works. Number 27, parallelogram ABCD is shown below. Using a compass and straight edge, construct the altitude from point A to side DC. Leave all construction marks. So let's just be clear. We're looking for a perpendicular. So let's talk about constructions. Constructions have to be done with a ruler and compass. To teachers, I actually teach constructions on the screen, because when you actually have the compass tool, you learn that the compass tool is literally just a circle drawing tool. And I actually force students to draw full circles, never just little arcs that look like dashes, because that procedure gets so confusing. Like where to put the dashes, why, that, no, draw circles, draw circles. And so as the student, draw circles and actually do the constructions on the screen. So I'm going to show you how to do this construction on the screen. Now, before we do the construction on the screen, we have to think about what it is that we want to construct. So parallelogram ABCDs from below, using a compass and straight edge, construct the altitude from point A to side DC. So from point A, the altitude is a perpendicular line to side DC. So what we want to draw is a line segment perpendicular to side DC. Okay, unfortunately we don't have software to draw perfectly straight lines, so it has to be constructed using the straight edge and the compass. Okay, so here we have a parallelogram, and if we actually move things around, we actually see that this really is in fact a parallelogram. Okay, so I did some minor construction on the side to make sure that it was a parallelogram, but now that we have this parallelogram, okay, let's make it look like the original rectangle ABCD. I'm sorry, the original parallelogram ABCD. And we did. Let's confirm. Okay. Now we what we said is we want to draw a perpendicular line that's from A to side CD. So the way to do that is to think about what shape has perpendicular lines in it naturally. And I think of a rhombus. A rhombus has perpendicular lines in it naturally. The diagonals are perpendicular bisectors of each other. So if I actually draw a rhombus, I get perpendicular lines for free. So how do I get a rhombus? I need to have line segments, 4 line segments that are same length as AD. I draw a circle from A to D. So center A, point on D. Now, why did I do that? Because every line segment that's congruent to AD that crosses A will have an endpoint on the circle. And how do I know that? Because a circle is literally the collection of points that are exactly the same distance from A as D is. So this line segment that I just drew right now has exactly the same length as AD. So I have part of a rhombus. Now, there's going to be a mystery point down here somewhere that has exactly the same distance from D and from this mystery point, which actually I'm going to label it for completeness. Point E. A mystery point from point A to point D that is equidistant from D as A. So, but where is it? Well, it's got to lie on a circle with the same radius as circle A. So in fact, if I draw a circle with center D to A, that circle has the same radius as circle A, because it literally has the same object AD as a radius. Same thing if I draw a circle from E to A. Now this circle has the same radius as the other two circles, because it has well, AE is a radius of circle A, and A in EA is a radius of circle E. So all the points on these two green circles are equidistant from D and E, and the same distance as A to D and E. So I'm going to draw that point right there. Now you don't have to label these points, but you have to draw the point. But there it is. So now, big deal. Notice this is now a rhombus. That is a rhombus, because AD, DE, EF, and EFD are all the same length, which means that if I draw an altitude from A to F, if I draw a line segment from A to F, and I draw a line segment from E to D, from D to E. Those line segments are perpendicular bisectors of each other, and specifically, it serves the purpose that we needed it to have, that it is an altitude. So I'm going to label that point G. Let's just confirm that it actually is a right angle. Look at this. That's a perfect right angle. So that did it. That did it. Now I'm actually going to undo, and I'm going to redo this construction again, just so you see it one time, without too much exposition. A circle from A to D gives me this new point, which I can label if I want to, and I like to label. That point is equidistant from E and D are equidistant to A. So that gives me a second line segment congruent to AD. And I draw a circle for center E towards to A and center D to A. The intersection of those two circles has to be equidistant from D and E. So I'm going to label that point. And then that gives me a rhombus. This is how I teach construction. So there are a few more steps that I'm taking that you don't have to take, but I promise you that taking the steps that I'm taking that are extra make it simpler, not tougher. Then I draw a line segment from A to F, and that is right there the perpendicular bisector. I'm sorry, not a perpendicular. Oh, it's the perpendicular bisector of DE, so it's perpendicular to AF to DC. Label that point G, and there it is. That's the construction. So that's the only one that I do on software. I don't do that one on paper. But the compass is just a circle drawing tool. So if you just think of it as a circle drawing tool, literally, and every student who I've taught constructions and taught them how to do them on paper, on software, I mean, has just been able to do them on paper without even struggling. Okay. So that's the best way to learn them. I advise you literally go on a Desmos, which is free, and do all your constructions on there. Okay. Number 28. Quadrilateral quad is graphed on the set of axes below. Determine and state the area of quadrilateral quad. There's a lot of ways to do this one. I've taught a few different ways specifically. You could draw a rectangle around quad and then subtract some right triangles. You could also break up quad into triangles. And in fact, these triangles are sufficiently nice that honestly, I think that's what I'm going to do. Let's see if it makes thick lines here. No. Yeah, that's entirely too thick now. So maybe I can increase the thickness though when I'm making straight lines so that they're more visible. There. And that's it, actually. Because now I have an altitude. Let me make a thicker one. And I have another altitude below it. There we go. I got to go back and change the thicknesses again, but you know what? Worth it, because now the lines are much more visible. Okay. So now QUA is a triangle with a horizontal base and a vertical height of 3, and a horizontal height length of let's count 1 2 3 4 5 6 7 8 9 10. That one I'm able to count. But if you can't count it, you could literally just do it manually. You could subtract the coordinates, the x coordinates to get the horizontal distance. You could subtract y coordinates to get the vertical distance. And this one also has a length of 3. So the area of QUAD is equal to the area of the top triangle QUA plus the area of the bottom triangle QDA, because their intersection is a line segment which has area 0. So they both have an area of 1/2 base in height. That's a B2H2. And so their areas are 1/2 base 1 is 10 times the height of 3 plus a height of 1/2 times a base of, again, 10 and another height of 3. And you could let the calculator do your arithmetic. You could go ahead and write 15 plus 15 is 30 or whatever you want to do. Literally let your calculator do this. It's 30. Okay? And this is a perfectly valid answer. Number 29, in a right triangle, the acute angles have a relationship sine of 3x minus 7 equals cos x plus 1. Determine and state the value of x. I gotta say, like, this question as is not asked exactly this way on any test except like New York State Regents. It's modified to make more sense for like SATs and ACTs. The way the Regents does it, I don't like giving a wag of the finger unless it's absolutely necessary. The way that the Regents makers write this problem on the Geometry Regents doesn't quite make sense because it requires you to assume something, and we are not in the business of assuming in math class. In fact, we actually are pretty insistent on not assuming, except for very minor things. Line segments that look straight are straight. Line segments that look like they intersect do intersect. Literally very minor things. When they graph a point and they want you to state the graph, the coordinates of the point, if they graphed it for you, it's got to be the obvious thing that they graphed. But here, that requires you to assume something. And it requires you to assume that this is in a right triangle and that the let me see if it'll draw a right triangle for me. It requires you to assume, after I try drawing a right triangle. Yep, nice. That the two angle measures are 3x minus 7, x plus 1. And I'm not a big fan of that. Unless they tell you that somehow. So it's a really poorly written problem. But that said, the old Regents asked this exact question, the new Regents asked this exact question, and I really don't tend to see this exact question written exactly this way on SATs and ACTs. They do ask the question, but they write it more appropriately. So a wag of the finger to the Regents makers. That said, notice that these angles have to be complementary. So 3x minus 7 and x plus 1 are complementary. So 3x minus 7 plus x plus 1 is equal to 90. And so combine the x's, you get 4x, combine the non-x's, minus 6 equals 90, plus 6 plus 6. We get 4x is equal to 96. Divide by 4, and you get that x is equal to 24. So it turned out to not even use the sine and the cosine. Not a fan. Not a fan again. But there are other ways to do it by graphing it, finding the intersection, and finding some relationship. I'm not a fan of the way it's written though. That's a big assumption. They should state that. They almost go and say it. They almost say it. The acute angles have the relationship of that, but they never state that these are the measures of the acute angles. It's really poor writing. That said, we are actually one problem away from getting an 80 on this Regents. Number 30 is going to give us the 80 on the Regents. So I'm really excited about it. We are on problem 30. You see how far through the test we have to get to an 80? It's actually quite far. If you remember, the multiple choice got us to a 73. But problem 30, which is actually a raw score of 60, gets us to an 80. Actually, 1 point off of that, 1 point into 30 gets us an 80, but the second point still keeps us at an 80. So yeah, it's actually tougher to get the extra points, but as a bonus though, it's actually easier to pass if you do work on these problems, because the later points are harder to get, but the earlier points are easier to get. Every single extra question that you answer boosts your grade by a lot. It's only later on that the grades kind of start, like you get more points, but your grade doesn't go up. 78, 78, 80, 80, 81, 82, 82, 84, 84. You see some of the numbers repeat. But earlier on, like instead of repeating numbers, in fact, it skips up a lot. 0 to 5 to 9. If you're over here, a 50 to 52 to 53, 54, 55, it skips some numbers. And then after a while, it starts to repeat 66, 66, 67, 67, 69, 69, 70, 70. So it starts to repeat later, but earlier on, it actually not only just doesn't repeat, but it actually skips a bunch. 46 to 48 here, 32 to 35. So those extra points early on get you closer to a passing grade much more quickly. And then when you get to the passing grade, getting higher than a passing grade, it gets tougher. Number 30, in circle A below, the measure of angle BAM is 36 degrees. Sure looks it. If AB is 20, let's put the 20 there, 20, determine and state the length of arc MB. Leave your answer in terms of pi. Okay. Some teachers recommend memorizing a formula. S, you call that arc length S, that's an S. Call this length R, and call this a central angle theta, so that S is equal to R theta times 2 pi over 360. If you want to memorize that, you can, but I actually prefer to use proportional reasoning, because proportional reasoning is a skill that permeates the entirety of math, sciences, chemistry, physics, bio, earth science, everything. Higher level classes you'll take in college, proportional reasoning. And so what things are proportional here? The length of the arc is proportional to the measure of the central angle. So we can write a proportion, theta, which is the central angle, that's the part of a circle, divided by the measure of the whole circle in degrees, 360. So that's the whole circle. Part of circle, theta, whole circle, 360. That's equal to the part of the circle, which is the arc length, S, divided by the measure, so that's the part of the circle, divided by the measure of the whole circle in length, which is 2 pi r, the circumference. And now we actually have the part over whole proportionality relation gives us the equation of that relates the arc length and the central angle. And so we get 36 degrees. We could plug into this equation and see what we get out of it. 36 degrees divided by 360 degrees, that's equal to the arc length S, which is a mystery number, divided by the circumference, which is 2 pi r. Now they did say leave it in terms of pi, which means we're not going to multiply the pi in as a decimal. Just keep it. I'm a big fan of simplifying, but a lot of students don't, and this is not an arithmetic test, so I'm not going to simplify here. But the 36 over 360 simplifies to 1 over 10. But I'm not going to do that. 36 times 2 pi r is equal to 360 Oh, and let's actually put the r in. 2 pi times 20 is equal to 360 times the mystery s, divided by 360, divided by 360. And again, I got to keep the pi in there, so I'm not going to multiply by the pi when I plug this into the calculator. I'm going to keep the pi next to the coefficient of that, which is, let's move the calculator back over here again. Let's see. The 36 times 2 times 20. I think it's going to be 2 times 2 divided by 360, which is 4. 4. 4 pi. 4 pi. 4 pi is the length of the arc. Number 31, in triangles ANT and ELM below, AN equals 6, it's down here, NT equals 5.6, okay, TA equals 4. That looks about right relative to size. The 5.6 even looks tiny bit smaller than the 6, right? The EL is 9, LM is 8.4, and ME is 6. Explain why ANT is similar to ELM. They said explain, so we need words. So that said, though, words and we could do math, and they tell us that these are similar triangles, and the order of the vertices, because of legal rules, have to match. So A has to correspond to E. N has to correspond to L, and then T. Oops. Come on, there we go. T has to correspond to M. Okay, there we go. So we could write proportions. So we could do AN, first and second vertex, over EL, first and second vertex, equals, let's see, AN, 6 over EL, 9, which is equal to 2 over 3. Let's actually go ahead and simplify these. I'm going to show you how to simplify these on the calculator, because the decimal one you're going to want to simplify. NT over that second and third vertex over LM second and third vertex equals NT over LM is 5.6 over LM 8.4. Now you might be stuck there because you're like, I don't know how to simplify a fraction. And again, this is not an arithmetic test. This is an algebra test. So as much as I would love to show you how to simplify this fraction, that's not the point of this video. The point of this video is to show you how to do this when you're taking the test. 8.4. Now, if you press the math button, arrow frac means convert to fraction. So 5.6 over 8.4, arrow frac, convert to fraction, 2/3. So, and then you could do, what's the last one? I did NA/NT, so TA over ME is equal to 4 over 6, which you could use the calculator again to simplify this, even if you did know how to simplify the first one, but not the second one. If you want to just let it do the third one, 2 over 3. It is 2 over 3. So all these fractions are the same. So the sides are proportional. So AN over EL equals NT over LM equals TA over ME equals 2 over 3. Since they're all equal to each other, the same proportion. Triangle ANT is similar to triangle ELM by the, now these are 3 proportional sides. This is the side proportionality relation. Sweet. And we just got a perfect part 3. That's solid. Part 2, rather. Sorry, we just got a perfect part 2, which is solid. All the 2-point problems are done. Now, you might be saying the part 3s are harder. So I have heard students and even some teachers evolve from saying, oh, I'm not going to just focus on the part ones, but I'm going to focus on the part ones and the part twos because the part threes and the part fours are just way too difficult. But in fact, the part threes and part fours are multi-part problems. You could actually get parts of the problem, and in fact, it almost always is the case that one half of the problem for a part three, one half of the problem is slightly easier than the other half of the problem. And in the part four problem, the single part four problem, sometimes it's the case that if it's three parts, that 1/3 of it will be easier than the other parts, and you can actually eke out a lot more points than you think. I've seen students who struggle with math get 5 out of 6 points in a part four problem. So keep that in mind. But here's the not necessarily drawn to scale. We're going to write the words almost definitely. And in fact, we haven't come across a single diagram that's not drawn to scale. And we're on problem 32 of 35. So that's a big deal. Number 32, a store sells colored craft sand in the 3 different containers below. Container 1, a square prism with a base length of 4 inches and a height of 7.5 inches. Container 2, a cylinder with a diameter of 5 inches and a height of 6 inches. Okay. And container 3, a cone with a diameter of 7.5 inches and a height of 8.5 inches. If the containers are filled to the top, which container will hold the most sand? Justify your answer. So which one will hold the most sand? It's the one with the larger volume. Because a larger volume holds more sand. Okay, so the container 1. It's at a square prism. So the bottom is a square. The bottom is a square with a base length of 4, so 4 and 4, and a height of 7.5. And we can go to the formula sheet to check the volume of a square prism, a general prism. Volume equals base times height, where B is the area of the base. So volume equals base times height, where B is the area of the base. So V equals side squared times H is equal to 4 squared times 7.5. And I'll let the calculator do that arithmetic. Let's move the calculator back to the side. Let's do 4 squared is 16 times 7.5. And we see the calculator says that that's 120. Container 2 and notice that I'm drawing diagrams. Big advice. Cylinder with a diameter of 5. Okay. A diameter of 5 and a height of 6. So if the diameter is 5, the radius is 2.5. Remember, D equals 2R. So 5 is equal to 2R divided by 2 divided by 2. We get that R is equal to 2.5. They're not trying to trick us by giving us the diameter and asking for the radius, something involving the radius. The volume is equal to, if we go back to the formula, we actually remember that it gives us a formula, base times height, where the B is the area of the base, and that base is a circle, pi r squared, H, which is equal to pi 2.5 squared times 6. Now this one, we want to get an estimate to compare the whole number 120. So pi 2.5 squared times 6 is 117.8097245. Okay. They didn't say to round anything. They didn't even tell us to get the numbers. But of course, how else are you going to do this problem without getting the numbers? And then finally, container 3 is a cone with a diameter of 7.5, 7.5, and a height, so h is equal to 8.5 inches. And so if the diameter is 7.5, the same way, d equals 2r, so 7.5 is equal to 2r divided by 2 divided by 2. So r, according to my calculator, is equal to 3.75. And so we get a volume, and that is on the we saw that it was already on the formula sheet. Is 1/3 base times height, which is, and the base is a circle, 1/3 pi r squared h, and so we got 1/3 pi times 3.75 squared times h is 8.5. And so the volume is approximately equal to, we're going to get the full decimal again, 1/3 times pi times r squared 3.75 squared times 8.5, and we get 125.1728323. And it said justify our answer, so justify the answer is enough to show the calculation. So container 3 is the largest. Which container will, what's the words? Will hold the most sand. So let's just say it that way. I could say is the largest, but they said which one will hold the most sand, so let's just say it that way. Container 3 will hold the most sand. Okay. That one's like literally just a test. Can you apply 3 different volume formulas? That's literally what they're testing. That's literally what they're testing. And then a little bit comparing. Okay. The subscribing, by the way, I'm already at 1,000 subscribers, but the subscriber count does help. So if this video has helped you, please do subscribe. Comment. I do answer questions in the comments. I don't know if you've noticed in my videos, a lot of students do ask questions, and I do answer them. Now, 2 more points on problem 33 is going to get us to 90. We are almost at a 90. Question 33 is going to do it for us. 2 more points is going to get us to 90. Number 33, quadrilateral mic has vertices with coordinates -1, -3, m -1, -3, I -3, +3, k 5, 4, and e 7, -2. Prove that mic is a parallelogram. Prove that mic is not a rhombus. The use of the set of axes is optional. I've found, generally speaking, that even though when the set of axes, using the set of axes is optional, that it's actually usually very helpful. So I had to zoom out a lot just to get the diagram and the numbers on the screen, but let's see if I could zoom in a little bit more. Okay, there you go. Let's m -1, -3, I -3, 3. You notice that I do this pretty quickly, but I do count. Okay. K 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. I just happen to have a weirdly keen eye to being able to tell exactly where points are. And 7, 6, 7 down -2. Okay. E. Okay. M. No, I am. M. Okay. So now this one, I'm gonna draw with thicker lines. Okay. Come on. Why does sometimes it makes it a straight line and other times it doesn't? There we go. Okay. So now I could zoom in. And I do find that using the uh the information given is actually, super helpful, especially when I use the graph, like I said. Um, so how am I going to do this one? I could show that this is a parallel, that it's a parallelogram by showing that the sides are parallel, but I'm noticing that then proving that it's not a rhombus might get a little difficult. Once I show that it's a parallelogram, I might have to do a bunch more math. If, however, I show that it's a parallelogram by proving that the opposite sides are congruent, then I could just use that math to show that it's not a rhombus. So let's do this. MI, the distance formula, the distance, so given point x1, y1, and x2, y2, parentheses, their distance is, by the Pythagorean theorem, d equals the square root of the difference in the x's, x2 minus x1 squared with parentheses, plus the difference in the y coordinates, y2 minus y1 squared. And so I'm actually going to apply this formula 4 times to get mi, mi, then ke, and then ik and me. So d mi is equal to the square root, and I got to do these in the right order. Let's see. So -3 minus a -1 squared plus a 3 minus a -3 squared. And I could actually, I'm allowed to do the arithmetic on the calculator. I could do -3 plus 1 in parentheses squared. What I'm not allowed to do is put a decimal when a decimal is not appropriate. And in this case, a decimal is not appropriate. So I get the square root of 2 squared plus 6 squared, which is equal to radical 4 plus 36, which is equal to radical 40. Or I could do in parentheses the stuff in the radical on the calculator, and it'll spit out 40, and I got to remember to put the radical. DKE is equal to the square root of the difference in their x's, 7 minus 5 squared, plus the difference in their y's, -2 minus 4 squared, which is equal to, again, radical 2 squared plus 6 squared, which is equal to radical 40. So DMI equals DKE. So MI is congruent to KE. So I've got that one pair of opposite sides of this quadrilateral are congruent. Now I have to show that the other pair of opposite sides are also congruent. So DIK is equal to the square root of the difference in the x coordinates, 5 parentheses 5 minus -3 squared plus the difference in the y's squared. So 4 minus 3 squared, which is equal to the square root of 8 squared plus 1 squared, which is equal to 64 plus radical 64 plus 1, which is equal to radical 65. Okay, and now DME is equal to the radical of the difference in the x coordinates, again, 7 minus -1 squared plus -2 minus a -3 squared, which is again equal to radical 8 squared plus 1 squared, which is equal to radical 64 plus 1, which is equal to radical 65. And since, so dik equals the distance to ME, from M to E, so ik is congruent to ME. I do have to put a dash on top of this. Line segment MI is congruent to line segment KE. And so now I've proved that both pairs of opposite sides are congruent. And so now I have to prove that it's a parallelogram but not a rhombus. Okay. So since MIKE has two pairs of opposite congruent sides, it is a parallelogram. However, since sides MI is not congruent to IK, or actually I should say that the lengths are not equal. Since MI is not equal to IK, MI, the line segment, is not congruent to IK, the line segment. So MIKE, Mike, does not have four congruent sides. Therefore, MIKE, Mike, is not a rhombus. There we go. I could have done it with parallel lines. I just saw myself saving a lot of work by not using parallel lines. Number 34. A park ranger needs to secure two different trees with wire. A wire is to be attached from a stake in the ground to each tree. The wire is attached at two different heights and two different angles of elevation as indicated in the model below. And I see a 4 feet 24 degrees, looks like a 24-degree angle, and I see a 3 foot, which is slightly lower than the 4, and a 11.6-degree angle, looks like that. And then it says that the park ranger has 20 feet of wire. Does the park ranger have enough wire to secure both trees? So that sounds like I need to get the lengths of the wires. Now, if I had to make a prediction, my answer would involve trying to interpret how long I think the wires are going to be. This wire here, if this were 30 degrees, the wire would be double the 4, which is 8. Since this is 24 degrees, this half of the wire is going to be longer than 8. And same thing happens with this one. Since this angle is tiny, relative to 3 feet, this wire is going to be way longer than 3. So I think that the second half, the right half of the wire is going to be way longer than 10. And then the left half of the wire is going to be slightly less than 10, I suspect. I have a feeling that he's not going to have enough wire. Can you make a... if you gave just a statement as an estimate, or if you said no because and you gave a valid reason, you might actually be able to get a point, but I need to do calculation here. This triangle on the left is a right triangle. This is the leg opposite the 24-degree angle, and this wire is the hypotenuse. So I need to get the length of this hypotenuse wire. I'm going to call this X. Just to give it a name. And so ka toa. Let's zoom in on this a little bit now that I can. I have the leg opposite and I have the hypotenuse that I'm looking for. So that's the sine. Sine of 24 is equal to the opposite 4 over the hypotenuse x. Let's do some cross multiplication. So x sine of 24 is equal to 4 times 1 is 4, divided by sine of 24. So x is approximately equal to, this is a case where I have to get a decimal approximation again. Let me move the calculator back over. A decimal approximation is appropriate since, since we just need to know that it's over 20 feet. And so we have to get some sort of decimal answer. 4 over sine 24 is just not enough information for most people to know how big that is, unless you use a calculator. 4 over sine 24 is equal to 9.83, 9.8343373342. Okay, let me minimize this. Okay, now I'm going to do the same thing with the right side wire. With the right side wire, I got that this is the leg opposite the 11.6 degree angle, and this is the hypotenuse, which I'm going to call it y. And I see again SOHCAHTOA, opposite of hypotenuse, sine of 11.6 is equal to the opposite 3 over the hypotenuse y. So I put this over 1 so I could do a cross multiplication, your favorite operation. I got 3 times 1 is 3 is equal to y times sine of 11.6 divided by the sine of 11.6 divided by the sine of 11.6 degrees. And I get that y is approximately equal to let's do the calculation. 3 over sine 11.6. So I said it was going to be over 10 by a lot. 14.919 to 919.5893. And now in this problem, I did confirm once again, do you need units in this one? Because the rule of thumb, generally speaking, is if they give you the units, you don't have to give the units. So they gave the units of the leg opposite as feet, so that the wire, when you're doing the problem with sine, is going to have a units of feet. So x has units of feet, y has units of feet, and that's known. So the wire length is going to be equal to these numbers, x plus y, which is equal to, and now we could actually do this on the calculator. We could actually let the calculator do these numbers. So this number, so I actually went up to x, pressed enter, and it types the number for me. Plus, now I'm going to go to the number that's y, and press enter, and it types the number for me. Press enter, and I get that x plus y is equal to 24.75396264. Okay, let me minimize the calculator now. That's a 3, I promise. So, and it said justify our answer. So x plus y is greater than 20 feet. So, the Ranger does not have enough wire. Okay, and we are legit one problem away from getting a perfect grade on this test. That's amazing. Congratulations, you've gotten a perfect part 3. That's it. So we're gonna finish number 35. We're gonna pick up the mic, we're gonna drop the mic, and we're gonna say congratulations, and that's gonna be it. But let's actually do this problem. First thing, not necessarily drawn to scale. Again, almost definitely. And I want to say, I said it before. on most tests. Usually one diagram is just barely not drawn to scale on geometry. Most diagrams are just period drawn to scale, period. But every once in a while you'll find a diagram that's just barely off of being perfectly drawn to scale, but that difference often just doesn't matter. Then there's a second situation in which the diagram technically has a degree of freedom. So technically something could be open or closed as much as it wants, and the diagram seems to not imply that because it's a piece of paper that's printed. So technically those aren't drawn to scale, technically. However, in almost all of those situations, you could still use scale to solve the problems. So assuming it's drawn to scale, if you don't know whether it's drawn to scale, is a great strategy. A significantly better strategy is confirming whether it's drawn to scale. We actually did confirm that every single diagram was drawn to scale. All right, so we are about to ace this test. This is our very last problem. So I'm super stoked about it. It says here, number 35, given quadrilateral carry, C-A-R-I, with CA congruent to RI, and CI congruent to RA, and AEI and LEH are just drawn. And prove that HA times EL equals LI times EH. All right, that was a lot. I'm going to do a quick highlight. HA times EL equals Li times EH. So it's striking me like a CPSTP. Corresponding parts of similar triangles are in proportion. I think that there's going to be two triangles that are similar, and then we're going to use similar triangle relations. Okay. And then we got to do the product of the means equals product of the extremes. So it's a good problem. It's a good problem. Fun fact though, a lot of students skip this one because they're like, the proofs are hard. But the more statements that are correct that you write, the more points you get. There's a lot of students who get 4 out of 6 problems, 4 out of 6 points, and don't know how to do this problem. It's a 6-point problem. Do you want to skip it? I don't think so. Let's see how many points you get if you skip this problem completely. If you do the problem correctly and do every single other problem correctly, you get an 80. So you're fighting between a 0 and 100. If you decide to skip this long proof problem, now you've skipped 6 points in your raw score, but that actually corresponds to 8 points in your scaled score. So now you're fighting a battle of 0 to 92. And you might be like, well, 0 to 92, I'm actually happy with a 92, except you're fighting for a 0 to 92, which means that if you get lower than a 92, proportionally speaking, you could have gotten a lot more points if you just did this problem. So I'm going to do this problem for sure. And I advise you to do it too. I'm going to do statement reason proof. And my first statement, I used to not do all the givens as a single statement, but now, whatever. I'm going to do that. So given quadrilateral CARI with CA congruent to RI, okay, top line congruent to the bottom line, that's a big deal, and CI congruent to RA. So that's the left side and the right side. So already I see that the outside is a parallelogram. So if I state that, probably a full point. And AEI notice that that's a diagonal of a parallelogram. That's probably relevant. And LEH are just drawn. And the reason for that is given. Unfortunately, most of the time, if you just write the givens, it's not enough for a point. But if you do a single more statement, that's a point. So is it worth doing that for a single point? I'm going to say yes, because a multiple choice is worth 2. So 1 point is half a multiple choice. All right. So and let's give a single correct statement. I noticed that the left is congruent to the right, the top is congruent to the bottom, so CARI is a parallelogram. And it's probably relevant to us. So CARI is a parallelogram because a quadrilateral with two pairs of opposite congruent sides is a parallelogram. And I got a point. So the top is congruent to the bottom and the left is congruent to the right. Now remember, my goal is really based on the sides that they want, the product proportion that they want me to write. It's to show that two triangles are similar. In fact, this triangle here and this triangle here, I'm going to show that they're similar. Remember, that's my ultimate goal. So how am I going to do that? I'm going to start stating that this angle is congruent to this angle because vertical angles are congruent. Angle HEA is congruent to angle LEI. And the reason they're vertical angles, so the reason is that vertical angles are congruent. Now, I'm actually going to go ahead. I'm actually going to try to get this angle and this angle congruent. Okay, that's my next step. I'm not going to draw that yet because I haven't proved it yet. But I noticed that the top and the bottom are parallel. CA is parallel to IR. CA is parallel to RI. So for CA is parallel to RI because, well, because the CARI is a parallelogram and opposite sides of a parallelogram are parallel. Opposite sides of a parallelogram are parallel. And then that immediately allows me to get that this angle is congruent to that angle. So I get that angle 5. I get that angle HAE is congruent to angle LIE. And the reason is that so if you notice that CA and IR are cut by transversal AI and alternate interior angles are congruent. So alternate interior angles are congruent. Alternate interior angles are congruent. And that makes the two triangles that I wanted to be similar. Triangle HEA is similar to triangle, let's get the vertices right, HEA, so LEI. Let's get this extended because by the angle postulate. If you can get to that point, you've already got 4 out of 6 points. You got 4 out of 6 points already if you were able to get to this point. So is it worth doing all this work? Absolutely. If you got part way to this, you could get 3 points. It doesn't take a lot of effort to actually get full credit for this one. You might find in proof problems that, and I'm going to move the subscribe button over here a little bit to the right so I could actually keep, oops, didn't mean to do that. I actually want the words to be not in the way. You'd be surprised when you're doing, yes, we're about to get the perfect 100. When you're doing proofs, that just writing down one detail that you know to be true at a time suddenly often gets you to the final exact answer. So in fact, I just said that these two triangles are similar, and now that means that the sides are proportional. And I got to use these sides, HA, EL, LI, and EJ, H. So HA EL, LI, and EH. Okay, so 7, I'm going to say that HE over LE, so that's first, second vertex, is equal to HA, first, third vertex, over IL, LI. LI. And the reason is, you could say CPSTP, or corresponding sides, corresponding parts of similar triangles are in proportion. Corresponding parts of similar triangles are in proportion. And then we're about to drop the mic, guys. We're literally about to drop the mic because we're about to give the very last reason. If you feel, and I gotta say this part, if you feel that this video has helped, and honestly, I think if you've made it to problem 35, I think this video has helped. If you feel like I've earned a subscribe, please do. If you feel like if you don't want to subscribe but you want to hit the like button, please do. If you have literally any questions, you could ask 5, 10, 15 questions in the comments and I'll answer them. This is I do that. If you feel like this video has helped you, please let me know. I do thrive on hearing that my videos have been appreciated. Okay, so I'm gonna give my very last comment, my very last step, and drop the mic. So I'm gonna multiply, cross multiply essentially. HA times, it's the final statement that they wanted us to prove. HA times EL is equal to LI times EH. And if you're wondering what just happened, I literally just cross multiplied. Now the reason you can give the reason cross multiplication, a common reason given using big people math is, ready, that the product of the means, I'm about to drop the mic here, I'm excited here, we're done. Product of the means is equal to the product of the EXTREMES period. We just got 100 on this test. Ready? Pick up the mic, drop the mic. We literally just aced this Geometry Regents. Congratulations. Thank you for making it all the way to this point, and I'll see you in the next video.